Synutix Linear. Data Manual. Volume 1. Communications. Philips. Synutix. Linear Products. 1989 Linear. Data Manual. Volume 1. Communications. Synutix reserves the right to make changes, without notice, in the products, including circuits, standard cells, and /or software, described or contained herein in order to improve design and /or performance. Synutix assumes no responsibility or liability for the use of any of these products, conveys no license or title under any patent, copyright, or mask work right to these products, and makes no representations or warranties that these products are free from patent, copyright, or mask work right infringement, unless otherwise specified. Applications that are described herein for any of these products are for illustrative purposes only. Synutix makes no representation or warranty that such applications will be suitable for the specified use without further testing or modification. Life support applications. Synutix products are not designed for use in life support appliances, devices, or systems where malfunction of a Synutix product can reasonably be expected to result in a personal injury. Synutix customers using or selling Synutix products for use in such applications do so at their own risk and agree to fully indemnify Synutix for any damages resulting from such improper use or sale. Synutix registers eligible circuits under the Semiconductor Chip Protection Act. Registered copyright 1966 Synutix Company, a division of North American Philips Corporation. All rights reserved. Synutix. Linear Products. The Linear Division, one of 4 Synutix product divisions, is a major supplier of a broad line of linear integrated circuits ranging from high-performance application-specific designs to many of the more popular industry standard devices. A 5th Synutix division, the Military Division, provides military-grade integrated circuits, including linear. Please consult the Synutix Military Data Book for information on such devices. Employing Synutix high-quality processing and screening standards, the Linear Division is dedicated to providing high-quality linear products to our customers worldwide. The 1989 Linear Data and Applications Manuals provide extensive technical data and application information for a December 1988. Preface. Broad range of products serving the needs of a wide variety of markets. Volume 1, Communications. Contains data and application information concerning our radio and audio circuits, companders, phase-locked loops, compact disc circuits, and ICS for RF communication, fiber optic communication, telephony, and modem applications. Volume 2 Industrial. Contains data and application information concerning our data conversion products, analog to digital and digital to analog, sample and hold circuits, comparators, driver/receiver ICS, amplifiers, position measurement devices, power conversion and control ICS, and music/speech synthesizers. Volume 3, Video. Contains data and application information concerning our video products. This 3 includes tuning, video if and audio if circuits, sync processors/generators, color decoders and encoders, video Sensing ICS, vertical deflection circuits, and power supply controllers for video applications. Each volume contains extensive product-specific application information. In addition, there are selector guides and product-specific symbols and definitions to facilitate the selection and understanding of linear products. A functional table of contents for each of the 3 volumes and a complete product and application note listing is also included. Although every effort has been made to ensure the accuracy of information in these manuals, Syniotix assumes no liability for inadvertent errors. Your suggestions for improvement in future editions are welcome. Syniotix product status. Linear products. Definitions. Datasheet. Product status definition. Identification. This datasheet contains the design target or goal. Ojek IV specm CIIL informative or indesilg specifications for product development. Specifications may change in any manner without notice. This datasheet contains preliminary data and supplementary realm LFI spec flow pre-production product. Data will be published at a later date. Signatulx Re88 N8S the right to make changes at any time without notice in order to improve design and supply the best possible product. This datasheet contains final spec FCATLONs. Syniotix. Product spec /TL on full production. Reserves the right to make changes at any ARN without notice in order to improve design and supply the best possible product. December 1988 4. Syniotix. Linear products. Section. General. 1. Information. Index. Contents of Volume 1, Communications. 1-3. Alphanumeric listing of all linear products. 1-8. Application note listing. By product group. 1-14. By part number. 1-17. Outline of contents of Volume 2, Industrial. 1-20. Outline of contents of Volume 3, Video. 1-21. Cross-reference guide by manufacturer. 1-22. Cross-reference guide by numeric list. 1-25. So availability list. 1-31. Ordering information. 1-33. Syniotix Volume 1. Communications. Contents. Linear products. Preface. Product status. Outline of contents. Section 1, General information. Contents of Volume 1, Communications. Alphanumeric listing of all linear products. Application note listing. By product group. By part number. Outline of contents of Volume 2, Industrial. Outline of contents of Volume 3, Video. Cross-reference guide by manufacturer. Cross-reference guide by numeric list. So availability list. Ordering information. Section 2, Quality and reliability. Quality and reliability. Section 3, Small area networks. Small area networks. Introduction to 12C. 12C bus specification. N168 the inter-integrated circuit, 12C, serial bus. Theory and practical considerations. PCF2100 4-segment LCD duplex driver. PCF2111 64-segment LCD duplex driver. PCF2112 32-segment LCD static driver. PCF8200 single-chip CMOS male/female speech synthesizer. PCF8570 256x8 static RAM. PCF8570 1LK serial RAM. PCF8570 3-clock/timer with 12C interface. PCF8570 48BLT remote I/O expander. PCF8576 universal LCD driver for low multiplex rates. PCF8577 32-64 segment LCD driver for automotive. PCF8583 256x8 BLT static RAM with alarm clock/calendar. PCF8591 8BLT A/D&D/A converter. SAA 1057 PLL radio tuning circuit. SAA 3028 IR receiver. SAB 3035 FLL TV tuning circuit, 80/A converters. SAB 3036 FLL TV tuning circuit. SAB 3037 FLL TV tuning circuit, 40/A converters. TDA 8440 AUDLO/VLDO switch. TDA 8442. TDA 8443. December 1988. I/O expander. RGB/YUV matrix switch. 1 to 3. 4. V. 1 to 3. 1 to 8. 1 to 14. 1 to 17. 1 to 20. 1 to 21. 1 to 22. 1 to 25. 1 to 31. 1 to 33. 2 to 3. 3 to 3. 3 to 4. 3 to 16. Vol 2. Voy 2. Vol 2. 8 to 6. Vol 2. Vol 2. Vol 2. Vol 2. Vol 2. Voy 2. Vol 2. Voy 2. 4 to 193. Voy 3. Vol 3. Vol 3. Vol 3. 7 to 210. Vol 3. Vol 3. Synthetix Linear Products. Volume 1, Communications Contents. Section 4, RF Communications. RF Signal Processing. Amplifiers. NE/SA5204. NE/SA/SE5205. NE/SE5539. N140. NE5592. NE/SE592. N141. Wideband High Frequency Amplifier. 4 to 3. Wideband High Frequency Amplifier. 4 to 13. Ultra High Frequency Operational Amplifier. 4 to 24. Compensation techniques for use with the NE/SE5539. 4 to 32. Video amplifier. 4 to 38. Video amplifier. 4 to 44. Using the NE/SE592 video amplifier. 4 to 53. Mixer/modulators/demodulators. MC1496/1596 balanced modulator/demodulator. 4 to 57. N189 balanced modulator/demodulator applications using the MC1496/MC1596. 4 to 61. NE602 double balanced mixer and oscillator. 4 to 66. N19S1 new low power single sideband circuits, NE602. 4 to 72. N1982 applying the oscillator of the NE602 in low power mixer applications. 4 to 80. NE612 low power VHF mixer/oscillator. 4 to 83. TDA1574 FM front end IC, VHF mixer and oscillator. 4 to 89. TDA 5030A VHF mixer oscillator, VHF tuner IC. 4 to 95. If systems. CA 3089. MC 3361. N 1992. NE/SA604A. N 1991. N 1993. NE605. NE614A. NE/SA615. TDA 1576. FM if system. 4 to 99. Low power FM if. 4 to 105. Using the Syniotix MC3361 demonstration board. 4 to 108. Low power FM if system. 4 to 114. Audio decibel level detector with meter driver, ... 4 to 124. High sensitivity applications of low power RF/if integrated circuits. 4 to 126. Low power FM if system. 4 to 137. Low power FM if system. 4 to 141. High performance low power mixer FM if system. 4 to 151. FM if, quadrature detector. 4 to 156. Single chip receivers. NE605 low power FM if system. 4 to 137. NE/SA615 high performance low power mixer FM if system. 4 to 151. TDA 7000 single chip FM radio cult. 7 to 41. TDA 7010 single chip FM radio circuit, SO package. 7 to 77. Frequency synthesis. Synthesizers. HEG 4750V. HEG 4751V. SAA 1057. N196. N197. TDD 1742. Frequency synthesizer. 4 to 163. Universal divider. 4 to 173. PLL radio tuning circuit. 4 to 182. Single chip synthesizer for radio tum. 4 to 190. Analysis and basic application of the SAA 1057, PLL radio tum. 4 to 197. CMOS frequency synthesizer. 4 to 209. Phase locked loops. N177. N178. NE/SE564. N179. N180. N1801. N181. N182. NE/SE565. N183. N184. NE/SE566. N185. N186. NE/SE567. N187. N188. NE568. December 1988. An overview of the phase locked loop, PLL. 4 to 222. Modeling the PLL. 4 to 227. Phase locked loop. 4 to 243. Circuit description of the NE564. 4 to 252. Frequency synthesis with the NE564. 4 to 259. 10.8 MHz FSK decoder with the NE564. 4 to 263. A 6 MHz FSK converter design example for the NE564. 4 to 266. Clock regenerator with crystal controlled phase locked VCO, NE564. 4 to 268. Phase locked loop. 4 to 277. Circuit description of the NE565 PLL. 4 to 283. Typical applications with NE565. 4 to 287. Function generator. 4 to 290. Circuit description of the NE566. 4 to 295. Waveform generators with the NE566. 4 to 296. Tone decoder / phase locked loop. 4 to 299. Circuit description of the NE567 tone decoder. 4 to 311. Selected circuits using the NE567. 4 to 316. 150 MHz phase locked loop. 4 to 319. 1 to 4. Synotics linear products. Volume 1, Communications Contents. Companders. And 174 applications for companders, NE570/571/SA571. And 176 Compander Cookbook. NE570/SA571 Compander. NE/SA572 Programmable Analog Compand or. And 175 Automatic Level Control using the NE572. NE575 Low Voltage Compander. Section 5, Data Communications. Line drivers / receivers. Definitions for line drivers. Symbols and AM26LS30. AM26LS31. AM26LS32/33. MC1488. MC1489/A. N113. NE5170. NE5180/81. Modems. NE5050. Dual differential Rs for 22-party line / quad single-ended. Quad high-speed differential line driver. Quad high-speed differential line receivers. Quad line driver. Quad line receivers. Using the MC1488/1489 line drivers and receivers. Octal line driver. Octal line resolver. Power line modem. Rs for 23 line driver. N1951. NE5080. NE5081. N195. N1950. NE5050 Power Line Modem Application Board Cookbook. High-Speed FSK Modem Transmitter, IEEE 802.4. High-Speed FSK Modem Receiver, IEEE 802.4. Applications using the NE5080/5081. Application of NE5080 and NE5081 with frequency deviation reduction. Fiber optics. NE5210 transimpedance amplifier. NE/SA5211 transimpedance amplifier. NE/SA/SE5212 transimpedance amplifier. NE/SA5214 post-amplifier with link status. NE/SA5217 post-amplifier with link status. NE568 150 MHz phase locked loop. Section 6, Telecommunications. Companders. Indicator. Indicator. N174. N176. Applications for companders NE570/571/SA571. Compander Cookbook. NE570/571/SA571. NE/SA572. N175. NE575. Compander. Programmable analog compender. Automatic level control using the NE572. Low voltage compender. Phase locked loops. ANL77. An overview of the phase locked loop, PLL. N178. Modeling the PLL. NE/SE564 phase locked loop. N179 circuit desktop of the NE564. N180 frequency synthesis with the NE564. N1801 10.8 MHz FSK decoder with the NE564. N181 a 6 MHz FSK converter design example for the NE564. N182 clock regenerator with crystal controlled phase locked VCO, NE564. NE/SE565 phase locked loop. N183 circuit description of the NE565 PLL. N184 typical applications with NE565. NE/SE566 Funclion generator. N185 circuit description of the NE566. N186 waveform generators with the NE566. NE/SE567 tone decoder / phase locked loop. N187 circuit description of the NE56. Tone decoder. N188 selected circuits using the NE567. NE568 150 MHz phase locked loop. Telephony. NE5900. PCD3310/A. December 1988. Call progress decoder. Pulse and DTMF dialer with redial. 1 to 5. 4 to 325. 4 to 334. 4 to 341. 4 to 348. 4 to 356. 4 to 357. 5 to 3. 5 to 4. 5 to 12. 5 to 18. 5 to 22. 5 to 26. 5 to 29. 5 to 32. 5 to 39. 5 to 44. 5 to 50. 5 to 78. 5 to 82. 5 to 86. 5 to 94. 5 to 97. 5 to 111. 5 to 125. 5 to 139. 5 to 146. 4 to 333. 4 to 325. 4 to 334. 4 to 341. 4 to 348. 4 to 356. 4 to 357. 4 to 222. 4 to 227. 4 to 243. 4 to 252. 4 to 259. 4 to 263. 4 to 266. 4 to 268. 4 to 277. 4 to 283. 4 to 287. 4 to 290. 4 to 295. 4 to 296. 4 to 299. 4 to 311. April 3, 16. 4 to 333. 6 to 3. 6 to 10. Synutix Linear Products. Volume 1, Communications Contents. PCD 3311/3312. PCD 3315. PCD 3341. PCD 3343. PCD 3360. PCD 4415. T1060/61. T1067. N1942. N1943. T1068. DTMF/modem/mus local tone generator. CMOS redial and repertory dialer. CMOS repertory telephone set controller. CMOS Melcra controller for telephone sets. Programmable multi-tone telephone ringer. Pulse and DTMF dialer with redial. Versatile telephone transmission circuits with dialer interface. Low voltage transmission IC with dialer interface. Application of the low voltage versatile transmission circuit. Supply of peripheral circuits with the TL067 speech circuit. Versatile telephone transmission circuit. 6 to 25. 6 to 37. 6 to 45. 6 to 55. 6 to 82. 6 to 90. 6 to 102. 6 to 113. 6 to 125. 6 to 145. 6 to 151. Section 7, Radial Audio. Radio Circuits. AM Radio. TDA 1072A. N1961. T5570. FM Radio. CA 3089. NE602. N1981. N1982. NE/SA604A. N1991. NE612. NE614A. TDA 1001B. TDA 1574. TDA 1576. TDA 7000. N192. N193. TDA 7010. TDA 7021. T5560. T5570. Stereo decoders. TDA 1578A. TDA 7040. T5581. P.A758. N191. AM receiver circuit. Integrated AM TDA 1072A receiver. AM/FM radio receiver circuit. FM if system. Double balanced mixer and oscillator. New low power single sideband circuits, NE602. Applying the oscillator of the NE602 in low power mixer applications. High performance low power FM if system. Audio decibel level detector with meter driver, NE604. Double balanced mixer and oscillator. Low power FM if system. Interference suppressor. FM front end IC, VHF mixer and oscillator. FM if system, quadrature detector. Single chip FM radio circuit. A complete FM radio on a chip. TDA 7000 for narrow band FM respalon. FM radio circuit, SO package. Single chip FM radio CIRCU2. FMI if system. AM/FM radio receiver circuit. PLL stereo decoder. PLL stereo decoder, low voltage. PLL stereo decoder. FM stereo multiplex decoder phase locked loop. Stereo decoder applications using the JJ.A758. 7 to 3. 7 to 15. 7 to 26. 4 to 99. 4 to 66. 4 to 72. 4 to 80. 4 to 114. 4 to 124. 4 to 83. 4 to 141. 7 to 35. 4 to 89. 4 to 156. 7 to 41. 7 to 46, 7 to 61, 7 to 77, 7 to 82, 7 to 88, 7 to 26, 7 to 96, 7 to 105, 7 to 111, 7 to 118, 7T23. Digital tuning circuits. SAA 1057 PLL radio tuning CIRCULT. 4 to 182. And 196 single chip synthesizer for radio tuning. 4 to 190. And 197 analysis and basic application of the SAA 1057 PLL radio tuning. 4 to 197. Audio circuits. Preamplifiers. NE542. and 190. Dual low noise preamplifier. 7 to 131. Applications of low noise stereo amplifiers NE542. 7 to 135. Tone/volume/switching. TDA 1029 stereo audio switch. 7 to 138. TDA 1074A DC controlled dual potentiometers. 7 to 147. TDA 1524A stereo audio control. 7 to 154. TDA 8440 video/audio switch IC. 7 to 162. T6300 digitally controlled tone, volume, and fader control circuli. 7 to 168. Dolby. NE5240. NE645/646. NE648/649. NE650. December 1988. Dolby Digital Audio Decoder. 7 to 178. Dolby Noise Reduclon Circuit. 7 to 182. Low Voltage Dolby Noise Reduclon Circuit. 7 to 187. Dolby B-Type Noise Reduclon Circuit. 7 to 192. 1 to 6. Synthetix Linear Products. Volume 1, Communications Contents. Power Amplifiers. Symbols and developments for audio power amplifiers. 7 to 197. TDA 10L0A. TDA 10LLA. TDA 1013A. and 148. TDA 1015. TDA 1020. TDA 1510. and 1491. TDA 1512. TDA 1514A. TDA 1515A. and 1481. TDA 1520B. and 149. TDA 1521. TDA 2611A. TDA 7050. TDA 7052. Compact disc. 6W audio amplifier with preamplifier. 7 to 198. 2 to 6W audio power amplifier with preamplifier. 7 to 203. 4W audio amplifier with DC volume control. 7 to 207. Audio amplifier with TDA 1013A. 7 to 210. 1 to 4W audio amplifier with preamplifier. 7 to 219. 12W audio amplifier with preamplifier. 7 to 224. 2x12W audio amplifier. 7 to 228. Car radio audio power amplifier up to 24W with the TDA i510. 7 to 232. 12 to 20W audio amplifier. 7 to 240. 40W high performance hi-fi amplifier. 7 to 245. 24 WBTL audio amplifier. 7 to 248. Car radio audio power amplifiers up to 20 W with the TDA 1515. 7 to 252. 20 W hi-fi audio amplifier. 7 to 259. 20 W hi-fi power amplifier with the TDA 1520A. 7 to 264. 2x12 hi-fi audio power amplifier. 7 to 269. 5W audio amplifier. 7 to 274. Low voltage mono/stereo power amplifier. 7 to 278. 1 watt low voltage audio power amplifier. 7 to 281. SAA 7210 decoder for compact disc digital audio system. 7 to 284. 7 to 298. 7 to 310. SAA 7220 digital filter for compact disc digital audio system. TDA 1541 dual 16 BLT digital to analog converter. Section 8, Speech I audio synthesis. OM8210 speech encoding and editing system. PCD 3311/3312 DTMF/modem/MUZ local tone generator. PCF 8200 single chip CMOS male/female speech synthesizer. SAA 1099 stereo sound generator for sound effects and music synthesis. Section 9, Packaging information. Substrate design guidelines for surface-mounted devices. Test and repair. Fluxing and cleaning. Thermal considerations for surface-mounted devices. Package outlines for prefixes ADC, AM, O, CA, DAC, ICM, LF, LM, MC, NE, SA, SE, SG, IJA, and UC. Package outlines for prefixes HEG, OM, PCD, PCF, PNA, SAA, SAB, TDA, TDD, and T. Section 10, Sales Office Listings. Sales Office Listings. December 1988 1 to 7. 8 to 3. 6 to 25. 8 to 6. 8 to 16. 9 to 3. 9 to 14. 9 to 17. 9 to 22. 9 to 35. 9 to 51. 10 to 3. Synotics. Linear products. ADC 0803/4/5. ADC 0820. AM26LS30. AM26LS31. AM26LS32/33. AM6012. O2901. O2902. O2903. O2904. CA3089. DAC08 series. HEG 4750V. HEG 4751V. ICM 7555. LF198. LF298. LF398. LM111. LM119. LM124. LM139/A. LM158. LM193/A. LM211. LM219. LM224. LM239/A. LM258. LM293/A. LM311. LM319. LM324. LM339/A. LM358. LM393/A. LM2901. LM2902. LM2903. LM2904, MC1408-7, MC1408-8, MC1458, MC1488, MC1489/A, MC1496, MC1508-8, MC1558, MC3302, MC3303, MC3361, MC3403, MC3410, MC3410C. December 1988. Alphanumeric. Product list. 8BLT CMOS8 converter. 8BLT CMOS8 converter. Dual differential RS422 party line quad single-ended RS423. Line driver. Quad high-speed differential line driver. Quad high-speed differential line receivers. 12 BLT multiplying DA converter. Quad voltage comparator. Low power quad operational amplifier. Low power dual voltage comparator. Low power dual operational amplifier. FMIF system. 8 BLT high speed multiplying DA converter. Frequency synthesizer. Universal divider. CMOS timer. Sample and hold amplifier. Sample and hold amplifier. Sample and hold amplifier. Voltage comparator. Dual voltage comparator. Low power quad operational amplifier. Quad voltage comparator. Low power dual operational amplifier. Low power dual voltage comparator. Voltage comparator. Dual voltage comparator. Low power quad operational amplifier. Quad voltage comparator. Low power dual operational amplifier. Low power dual voltage comparator. Voltage comparator. Dual voltage comparator. Low power quad operational amplifier. Quad voltage comparator. Low power dual operational amplifier. Low power dual voltage comparator. Quad voltage comparator. Low power quad operational amplifier. Low power dual voltage comparator. Low power dual operational amplifiers. 8 BLT multiplying DA converter. 8 BLT multiplying DA converter. General purpose operational amplifier. Quad line driver. Quad line receivers. Balanced modulator/demodulator. 8 BLT multiplying DA converter. General purpose operational amplifier. Quad voltage comparator. Quad low power operational amplifier. Low power FMIF. Quad low power operational amplifier. 10 BLT high speed multiplying DA converter. 10 BLT high speed multiplying DA converter. 1 to 8. Vol 1, Vol 2, Vol 3. 5 to 11. 5 to 24. 5 to 4. 5 to 12. 5 to 18. 5 to 99. 5 to 229. 4 to 29. 5 to 234. 4 to 35. 4 to 99. 5 to 90. 4 to 163. 4 to 173. 7 to 3. 5 to 306. 5 to 306. 5 to 306. 5 to 239. 5 to 242. 4 to 40. 5 to 248. 4 to 141. 5 to 255. 5 to 239. 5 to 242. 4 to 40. 5 to 248. 4 to 141. 5 to 255, 5 to 239, 5 to 242, 4 to 40, 5 to 248, 4 to 141, 5 to 255, 5 to 248, 4 to 40, 5 to 255, 4 to 141, 5 to 123, 5 to 123, 4 to 47, 5 to 22 6 to 4, 5 to 26 6 to 8, 4 to 57, 5 to 123, 4 to 47, 5 to 248, 4 to 53, 4 to 105, 4 to 53, 5 to 129, 5 to 129. Syntactics linear products. Alphanumeric product list. MC3503, MC3510, NE/SE521, NE/SE522, NE/SE527, NE/SE529, NE/SE530, NE/SE531, NE/SA532, NE/SE538, NE542, NE544, NE/SE555, NE/SA/SE556/1, NE/SA/SE558, NE/SE564, NE/SE565, NE/SE566, NE/SE567, NE568, NE570, NE/SA571, NE/SA572, NE575, NE587, NE589, NE590, NE591, NE/SE592, NE/SA594, NE602, NE/SA604A, NE605, NE612, NE/SA614A, NE/SA615, NE645, NE646, NE648, NE649, NE650, NE/SE4558, NE/SE5018, NE/SE5019, NE5020, NE5034, NE5036, NE5037, NE5044, NE5045, NE5050, NE5060, NE5080, NE5081, NE5090, NE/SA/SE51051A, NE/SE5118, NE/SE5119, NE5150, NE5151, NE5152, NE5170, NE5180. December 1988. Quad Low Power Operational Amplifier. 10-bit high-speed multiplying DA converter. High-speed dual differential comparatorial sense amp. High-speed dual differential comparatorial sense amp. Voltage comparator. Voltage comparator. High slew rate operational amplifier. High slew rate operational amplifier. Low power dual operational amplifier. High slew rate operational amplifier. Dual low noise preamplifier. Servo amplifier. Timer. Dual timer. Quad timer. Phase locked loop. Phase locked loop. Function generator. Tone decoder / phase locked loop. 150 MHz phase locked loop. Compand OR. Compand OR. Programmable analog compander. Low voltage compander. LED decoder / driver. LED decoder / driver. Addressable peripheral drivers. Addressable peripheral drivers. Video amplifier. Vacuum fluorescent display driver. Low power VHF Melser / oscillator. High performance low power FM if system. Low power FM if system. Low power VHF Melser / oscillator. Low power FM if system. High performance low power mixer FM if system. Dolby noise reduction circuit. Dolby noise reduction circuit. Low voltage Dolby noise reduction circuit. Low voltage Dolby noise reduction circuit. Dolby B-type noise reduction circuit. Dual general purpose operational amplifier. 8BLT microprocessor compatible DA converter. 8BLT microprocessor compatible DA converter. 10BLT microprocessor compatible DA converter. 8BLT high-speed 8 converter. 6BLT 8 converter, serial output. 6BLT 8 converter, parallel outputs. Programmable 7-channel RC encoder. 7-channel RC decoder. Power line modem. Sample and hold circuit. High-speed FSK modem transmitter. High-speed FSK modem receiver. Addressable relay driver. 12BLT high-speed comparator. 8BLT microprocessor compatible DA converter. 8-bit microprocessor compatible DA converter. RGB video DA converter. RGB video DA converter. RGB video DA converter. Octal line driver. Octal line receiver. 1 to 9. Vol 1. 7 to 131. 4 to 243. 4 to 277. 4 to 290. 4 to 299. 4 to 319. 4 to 341. 4 to 341. 4 to 348. 4 to 357. 4 to 44. 4 to 66. 4 to 114. 4 to 137. 4 to 83. 4 to 141. 4 to 151. 7 to 182. 7 to 182. 7 to 187. 7 to 187. 7 to 192. 5 to 44. 5 to 78. 5 to 82. 5 to 32. 5 to 39. Vol 2. 4 to 53. 5 to 129. 5 to 274. 5 to 279. 5 to 285. 5 to 290. 4 to 66. 4 to 73. 4 to 141. 4 to 81. 8 to 33. 7 to 48. 7 to 33. 7 to 39. 6 to 53. 6 to 63. 6 to 34. 6 to 34. 4 to 244. 6 to 78. 4 to 214. 4 to 61. 5 to 137. 5 to 143. 5 to 149. 5 to 37, 5 to 44, 5 to 51, 8 to 4, 8 to 15, 5 to 311, 6 to 28, 5 to 261, 5 to 157, 5 to 157, 5 to 169, 5 to 169, 5 to 169, 6 to 14, 6 to 21, Vol 3, 11 to 3, 11 to 93, 11 to 19, 11 to 19, 11 to 19, Synthetix linear products. Alphanumeric product list. Vol 1, Vol 2, Vol 3. NE5181 octal line receiver 5 to 39, 6 to 21. NE5204 oldie bond high frequency amplifier 4 to 3, 4 to 170, 11 to 52. NE/SA/SE5205 wide band high frequency amplifier 4 to 13, 4 to 180, 11 to 62. NE5210 transimpedance amplifier, 280 MHz, 5 to 97, 4 to 279. NE/SA5211 transimpedance amplifier, 180 MHz, 5 to 111, 4 to 293. NE/SA5212 transimpedance amplifier, 140 MHz, 5 to 125, 4 to 307. NE/SA5214 post amplifier with link status indicator 5 to 139, 4 to 321. NE/SA5217 fiber optic post amplifier with link status indicator 5 to 146, 4 to 328. NE/SA5230 low voltage operational amplifier 4 to 122. NE5240 Dolby digital audio decoder 7 to 178. NE/SE5410 BLT high speed multiplying DA converter 5 to 196. NE/SE5512 dual high performance operational amplifier 4 to 88. NE/SE5514 quad high performance operational amplifier 4 to 94. NE5517 a dual operational transconductance amplifier 4 to 263. NE5520 LVDT signal conditioner 5 to 324. NE/SE5521 LVDT signal conditioner 5 to 354. NE/SE55321A internally compensated dual low noise operational amp 4 to 100. NE5533 a single and dual low noise operational amp 4 to 106. NE5534 a single and dual low noise operational amp 4 to 106. NE/SE5535 dual high slew rate op amp 4 to 148. NE/SE5537 sample and hold amplifier 5 to 316. NE/SE5539 ultra high frequency operational amplifier 4 to 24, 4 to 224, 11 to 73. NE/SE5560 switched mode power supply control circuit 8 to 73. NE/SE5561 switched mode power supply control circuit 8 to 102. NE/SLSE5562 SMPS control circuit, single output 8 to 113. NE5568 switched mode power supply controller 8 to 145. NE/SA/SE5573 phase brushless DC motor driver 8 to 44. NE5592 video amplifier 4 to 44 to 238, 11 to 87. NE5900 call progress decoder 6 to 3. OM8210 speech encoding and editing system 8 to 3. PCD33 10 pulse and DTMF dialer with redial 6 to 10. PCD33 11 DTMF modem /mus local tone generator 6 to 25. PCD33 12 DTMF modem /mus local tone generator 6 to 25. PCD33 15 CMOS redial and repertory dialer 6 to 37. PCD33 41 CMOS repertory telephone set controller 6 to 45. PCD33 43 CMOS Melcra controller for telephone set 6 to 55 9 to 3. PCD33 60 programmable multi-tone telephone ringer 6 to 82. PCD44 15 pulse and DTMF dialer with redial 6 to 90. PCF2100 LCD duplex driver 6 to 83. PCF2111 LCD duplex driver 6 to 90. PCF2112 LCD driver 6 to 95. PCF8200 single chip CMOS male/female speech synthesizer 8 to 6. PCF8566 universal LCD driver for low multiplex rate 6 to 100. PCF8570-256x8 static RAM 9 to 34 to 3. PCF8571 1K serial RAM 9 to 38 4 to 11. PCF8573 clock/calendar with serial 1/09 to 46 4 to 19. PCF8574 8BLT remote 1/0 expander 9 to 57 4 to 30. PCF8576 universal LCD driver for low multiplex rate 6 to 120. PCF8577 32/64 segment LCD driver for automotive 6 to 141. PCF8582A12C CMOS EPROM 256x8 9 to 65 4 to 38. PCF8583 256x8 BLT static RAM with alarm clock/calendar 7 to 23. PCF8591 8-bit 8 and D/A converter 5 to 59. PNA75097 BLT 8 converter 5 to 72 11 to 9. SA532 low power dual operational amplifier 4 to 100. SA534 low power quad operational amplifier 4 to 40. SA556/1 dual timer 7 to 33. SA558 quad timer 7 to 39. SA571 compander 4 to 341. SA572 programmable analog compander 4 to 348. SA594 vacuum fluorescent display driver 6 to 78. SA604A 4 to 114 4 to 191. SA614A 4 to 141 4 to 214. SA615 high performance low power mixer FM if system 4 to 151. December 1988 1 to 10. Synthetix Linear Products 3. Alphanumeric Product List. Vol 1 Vol 2 Vol 3. SA723C Precision Voltage Regulator 8 to 235. SA741C General Purpose Operational Amplifier 4 to 157. SA747C Dual Operational Amplifier 4 to 163. SA1458 General Purpose Operational Amplifier 4 to 47. SA5205 Wideband High Frequency Amplifier 4 to 13 4 to 180 11 to 62. SA5211 Transimpedance Amplifier 5 to 111 4 to 293. SA5212 Transimpedance Amplifier 5 to 125 4 to 307. SA5214 Transimpedance Amplifier 5 to 139 4 to 321. SA5217 Transimpedance Amplifier 5 to 146 4 to 328. SA5230 low voltage operational amplifier 4 to 122. SA5534A single and dual low noise operational amp 4 to 106. SA5562 SMPS control circuit, single output 8 to 113. SA5573 phase brushless DC motor Denver 8 to 44. SA1057 PLL radio tuning circuit 4 to 182. SA1064 4DLGLT LED Denver with 12C bus interface 6 to 153. SA1099 stereo sound generator for sound effects and music 8 to 16. SA3004 IR transmitter, 448 commands, 5 to 3. SA3006 IR transmitter, 2K commands, low voltage, 5 to 19. SA3027 IR transmitter 5 to 28. SA3028 IR remote control transcoder with 12C 5 to 37. SA7210 compact disc decoder 7 to 284. SA7220 digital filter and interpolator for compact disc 7 to 298. SAB3035 FLL tuning and control circuit, 80/A converters, 4 to 50. SAB3036 FLL tuning and control circuit 4 to 65. SAB3037 FLL tuning and control circuit, 40/A converters, 4 to 75. SE521 high-speed dual differential comparator / sense amp 5 to 274. SE522 high-speed dual differential comparator / sense amp 5 to 279. SE527 voltage comparator 5 to 285. SE529 voltage comparator 5 to 190. SE530 high slew rate operational amplifier 4 to 66. SE531 high slew rate operational amplifier 4 to 73. SE532 low power dual operational amplifier 4 to 141. SE538 high slew rate operational amplifier 4 to 81. SE555 timer 7 to 48. SE555C timer 7 to 48. SE556-1C dual timer 7 to 33. SE556/-1 dual timer 7 to 33. SE558 quad timer 7 to 39. SE564 phase locked loop 4 to 243. SE565 phase locked loop 4 to 277. SE566 function generator 4 to 290. SE567 tone decoder / phase locked loop 4 to 299. SE592 video amplifier 4 to 44 4 to 244 11 to 93. SE4558 dual general purpose operational amplifier 4 to 61. SE5018 8BLT microprocessor compatible 0/A converter 5 to 137. SE5019 8BLT microprocessor compatible 0/A converter 5 to 143. SE5118 8BLT microprocessor compatible 0/A converter 5 to 157. SE5119 8BLT microprocessor compatible 0/A converter 5 to 157. SE5205 wideband high frequency amplifier 4 to 13 4 to 180 11 to 62. SE5212 transimpedance amplifier 5 to 125 4 to 267. SE5410 10BLT high-speed multiplying 0/A converter 5 to 208. SE5512 dual high-performance operational amplifier 4 to 88. SE5514 quad high-performance operational amplifier 4 to 94. SE5521 LVDT signal conditioner 5 to 354. SE5532/A internally compensated dual low noise operational amp 4 to 100. SE5534A single and dual low noise operational amp 4 to 106. SE5535 dual high slew rate up amp 4 to 148. SE5537 sample and hold amplifier 5 to 316. SE5539 ultra high frequency operational amplifier 4 to 24 4 to 224 11 to 73. SE5560 switched mode power supply control circuit 8 to 73. SE5561 switched mode power supply control circuit 8 to 102. SE5562 SMPS control circuit, single output 8 to 113. SE5573 phase brushless DC motor Denver 8 to 44. December 1988 1 to 11. Synthetix linear products. Alphanumeric product list. Vol 1 Vol 2 Vol 3. SG1524C improved SMPS push-pull controller 8 to 147. SG2524C improved SMPS push-pull controller 8 to 147. SG3524 SMPS control circuit 8 to 200. SG3524C improved SMPS push-pull controller 8 to 147. SG3526 switched mode power supply control circuits 8 to 216. TDA 1001B interference suppressor 7 to 35. TDA 1010A6W audio amplifier with preamplifier 7 to 198. TDA 1011A2 to 6W audio power amplifier with preamplifier 7 to 203. TDA 1013A4W audio amplifier with DC volume control 7 to 207. TDA 1015 1 to 4W audio amplifier with preamplifier 7 to 219. TDA 1020 12W audio amplifier with preamplifier 7 to 224. TDA 1023 time proportional triac trigger 8 to 268. TDA 1029 stereo audio switch 7 to 138. TDA 1072 AAM receiver circuit 7 to 3. TDA 1074 A DC controlled dual potentiometers 7 to 147. TDA 1510 2X12W audio amplifier 7 to 228. TDA 1512 12 to 20W audio amplifier 7 to 240. TDA 1514 A40W high performance hi-fi amplifier 7 to 245. TDA 1515 A24W BTL audio amplifier 7 to 248. TDA 1520 B20W hi-fi audio amplifier 7 to 259. TDA 1521 2X12W hi-fi audio power amplifier 7 to 269. TDA 1524 A stereo tonal volume control circuit 7 to 154. TDA 1534 14 BLTA/D converter, serial output 5 to 82. TDA 1541 16 BLT dual D/A converter, serial output 7 to 310 5 to 217. TDA 1574 FM front end IC, VHF mixer and oscillator, 4 to 89. TDA 1576 FM if system 4 to 156. TDA 1578 APLL stereo decoder 7 to 96. TDA 2545 A quasi split sound if system 8 to 3. TDA 2546 A quasi split sound if and sound demodulator 8 to 6. TDA 2577 A sync circuit with vertical oscillator and driver 9 to 3. TDA 2578 A sync circuit with vertical oscillator and Denver 9 to 14. TDA 2579 synchronel Zola in circuit 9 to 31. TDA2582 control circuit for power supplies 13-3. TDA2593 horizontal combination 9-41. TDA2594 horizontal combination 9-46. TDA2595 horizontal combination 9-51. TDA2611A5W audio output amplifier 7-274. TDA2653A vertical deflection circuit with oscillator 12-3. TDA3047IR preamplifier 5-42. TDA3048IR preamplifier 5-46. TDA3505 chroma control circuit 10-11. TDA3566 PAL/NTSC decoder with RGB inputs 10-18. TDA3567 NTSC color decoder 10-60. TDA3654 vertical defleclion 12-9. TDA4501 small signal subsystem IC for color TV 6-3. TDA4502 complete video if IC with vertical and horizontal sync 6-13. TDA4503 small signal subsystem for monochrome TV 6-15. TDA4505 small signal subsystem IC for color TV 6-24. TDA4555 MULA standard color decoder 10-38. TDA4565 color transient improvement circuit, CTI, 10-53. TDA4570 NTSC color difference decoder 10-57. TDA4580 video control combination circuit with automatic cut-off control 10-62. TDA5030A VHF mixer oscillator, VHF tuner IC, 4-95 4-80. TDA5040 brushless DC motor driver 8-63. TDA7000 single chip FM radio circuit 7-41. TDA7010 single chip FM radio circuit, SO package, 7-77. TDA7021 single chip FM radio circuit 7-82. TDA7040 PLL stereo decoder, low voltage, 7-105. TDA7050 low voltage mono/stereo power amplifier 7-278. TDA7052 1 watt low voltage audio power amplifier 7-281. TDA8340/41 television if amplifier and demodulator 7-3. TDA8440 VLDO/audio switch 7-210 11-46. TDA8442 quad DAC with 1-2C interface 10-101. December 1988 1-12. Synutix linear products. Alphanumeric product list. Vol 1 Vol 2 Vol 3. TDA8443/URG by YUV switch inputs 10-107. TDA8444 octuple 6BL TDA converter with 1C2 bus 5222. TDD1742 CMOS frequency synthesizer 4209. TL039 control circuit for SULCHT mode power supply 8227 1312. T1060 telephone transmission circuit with dialer interface 6102. T1061 telephone transmission circuit with dialer interface 6102. T1067 low voltage transmission IC with dialer interface 6113. T1068 low voltage transmission IC with dialer interface 6151. T5560 FM if system 788. T5570 AM/FM radio receiver circuit 726. T5581 PLL stereo decoder 7111. T6300 digitally controlled tone, volume, and fader control circuit 7168. UC1842 current mode PWM controller 8241. UC2842 current mode PWM controller 8241. UC 3842 current mode PWM controller 8241. PA 723 precision voltage regulator 8235. PA 723C precision voltage regulator 8235. A733 differential video amplifier 425711 to 106. P.A733/C differential LAL video amplifier 425711 106. A741 general purpose operational amplifier 4157. P.A741C general purpose operational amplifier 4157. A747 dual operational amplifier 4 to 163. A747C dual operational amplifier 4163. A758 FM stereo multiplex decoder phase locked loop 7118. December 1988 113. Synutics application notes. By product group. Linear products. Signal processing. N140. N141. N1981. N1982. N1991. Compensation techniques for use with the NE/SE5539. Using the NE592/5592 video amplifier. New low-power single-sideband circuits, NE602. Applying the oscillator of the NE602 in low-power mixer applications. Audio decibel level detector with meter driver. Frequency synthesis. N196. N197. Single chip synthesizer for radio tuning. Analysis and basic application of the SAA 1057, VBA 8101. Phase locked loops. N177. N178. N179. N180. N1801. N181. N182. N183. N184. N185. N186. N187. N188. Companders. N174. N175. N176. An overview of phase locked loops, PLL. Modeling the PLL. Circuit description of the NE564. The NE564 frequency synthesis. 108 MHz FSK decoder with the NE564. A 6 MHz FSK converter design example for the NE564. Clock regenerator with crystal controlled phase locked VCO. Circuit description of the NE565. Typical applications with NE565. Circuit description of the NE566. Waveform generators with the NE566. Circuit description of the NE567 tone decoder. Selected circuits using the NE567. Applications for companders, NE570/571/SA571. Automatic level control NE572. Compander cookbook. Line drivers/receivers. N113. N195. N1950. N1951. Telephony. N1942. N1943. Radio circuits. N1961. N1981. N1982. N191. N192. N193. N1991. N1992. N1993. December 1988. Applications using the MC1488/1489 line drivers and receivers. Applications using the NE5080/5081. Application of NE5080 and NE5081 with frequency deviation reduction. NE5050 Power Line Modem Application Board Cookbook. T1067 Application of the Low Voltage Versatile Transmission Circuit. T1067 Supply of Peripheral Circuits with the T1067 Speech Circuit. TDA1072A. Integrated AM Receiver. New Low Power Single Sideband Circuits, NE602. Applying the oscillator of the NE602 in Low Power Mixer Applecollins. Stereo Decoder Applecollins using the PA758. A complete FM radio on a chip. TDA7000 for narrowband FM Receptlon. Audio decibel level detector with meter driver, NE604A. Using the Sygnutix MC3361 demonstration board. High sensitivity applicants of low power VIF integrated circuits. 1 to 14. Vol 1. 4 to 32. 4 to 53. 4 to 72. 4 to 80. 4 to 124. 4 to 190. 4 to 197. 4 to 222. 4 to 227. 4 to 252. 4 to 259. 4 to 263. 4 to 266. 4 to 268. 4 to 283. 4 to 287. 4 to 295. 4 to 296. 4 to 311. 4 to 316. 4 to 325. 4 to 356. 4 to 334. 5 to 29. 5 to 86. 5 to 94. 5 to 50. 6 to 125. 6 to 145. 7 to 15. 4 to 72. 4 to 80. 7 to 123. 7 to 46. 7 to 61. 4 to 124. 4 to 108. 4 to 126. Vol 2. 4 to 232. 4 to 253. 4 to 201. 6 to 11. 4 to 201. 4 to 203. Vol 3. 11 to 81. 11 to 102. Sygnutix Linear Products. Application Notes by Product Group. Vol 1, Vol 2, Vol 3. Audio Circuits. N148 Audio Amplifier with TDA 1013-7 to 210. N1481 Car Radio Audio Power Amplifiers up to 20 W with the TDA 1515-7 to 252. N149 20W Hi-Fi Power Amplifier with the TDA 1520A7 to 264. N1491 Car Radio Audio Power Amplifiers up to 24W with the TDA 1510-7 to 232. N190 Applications of Low Noise Stereo Amplifiers, NE542-7 to 171. Operational Amplifiers. N142 Audio Circuits using the NE5532/33/34 4 to 114. NE44 Applications for the NE5512 and NE5514 4 to 91. N1441 Applications for the NE5514 4 to 97. N1511 Low Voltage Gated Generator, NE5234 to 134. N1512 All-in-One. NE5234 to 136. NE60 Applications for the MC34034 4 to 58. NE64 Explanation of Noise 4 to 8. N165 Integrated Operational Amplifier Theory 4-18. N166 Basic Feedback Theory 4-25. High Frequency Amps. N1991 Audio Decibel Level Detector with Meter Driver 4-124 4-210. Video Amps. N140 Compensation Techniques for use with the NE/SE5539 4-32 4-232 11-81. N141 using the NE592/5592 Video Amplifier 4-53 4-253 11-102. Transconductance. N145 NE5517, General Description and Applications for use with the NE5517/A4 276. Transconductance Amplifier. Data Conversion. N100 An Overview of Data Converters 5-3. N10L Basic DACs 5-90. N105 Digital Attenuator 5-97. ANI06 using the DAC08 without a negative supply 5-122. N108 An Amplifying, Level Shifting Interface for the PNA7509 Video DA Converter 5-81 11-18. N1081 NE5150/51152, Family of Video D/A Converters 5-176 11-26. N109 Microprocessor Compatible DACs 5-162. Comparators. N116 Applications for the NE521152/527/529 5-295. N1161 12-bit 8 converter using the NE5105 comparator 5-269. Position measurement. N118 LVDT signal conditioner, applications using the NE5525 329. N1180 a microprocessor-based servo loop for linear position control 5-344. N1181 NE5521 in a modulated light source design application 5-359. N1182 NE5521 in mule-faceted applications 5-363. Line drivers/receivers. N113 applications using the MC148811489 line drivers and receivers 5-29 6-11. Display drivers. N112 LED decoder drivers, using the NE587 and NE589 6-72. Timers. N170 NE555 and NE556 applications 7-54. N171 NE558 applications 7-43. December 1988 1-15. Synutix Linear Products. Application Notes by Product Group. Motor Control and Sensor Circuits. N28T. N131. N1311. N132. N133. N1341. NE5570, A Theory of Operation and Applications. Applications using the NE5044 encoder. Low-cost aid conversion using the NE5044. Applicalons using the NE5045 decoder. Applications using the NE544 servo amplifier. Control system for home computer robotics. Switched mode power supply. N120. N1211. N122. N1221. N123. N124. N125. N126. N1261. N1262. N128. N1291. Tuning circuits. N157. An overview of SMPS. A microprocessor controlled switched mode power supply. NE5560 push-pull regulator applicalon. Switched mode drives for DC motors. NE5561 applicalons. External synchronels alon for the NE5561. Progress in SMPS magnetic component optimization. Applicalons using the SG3524. High-frequency ferrite power transformer and choke. Theory of operation and applicalons for SG1524C/2524C/3524C. Introduction to the Sanes resonant power supply. TDA 1023, Design of time proportional temperature controls. Microcomputer peripheral IC tunes and controls a TV set SAB3035. Remote control system. N172. N173. N1731. Circuit description of the infrared receiver TDA3047/TDA3048. Low power preamplifiers for IR remote control systems. SAA 3004, low power remote control IR transmitter and receiver. Preamplifiers. Sync processing and generator. N158. N162. N1621. Features of the TDA2595 synchronization processor. A versatile high-resolution monochrome data and graphics. Directives for a print layout design on behalf of the IC combination TDA2578A and TDA3651. Color decoding and encoding. N155/A. N1551. December 1988. Multi-standard color decoder with picture improvement. Single-chip multi-standard color decoder TDA4555/4556. 1 to 16. Vol 1, Vol 2, Vol 3. 8 to 49. 8 to 11. 8 to 13. 8 to 21. 8 to 39. 8 to 22. 8 to 68. 8 to 88. 8 to 94. 8 to 97. 8T07. 8 to 112. 8 to 250. 8 to 214. 8T54. 8 to 200. 8 to 260. 8 to 276. 4 to 55. 5 to 50. 5 to 52. 5 to 10. 9 to 57. 9 to 25. 9 to 30. To 3. To 44. Synthetix. Linear products. DAC 08 and 10L. N106. MC 1488 and 113. MC 1489/A and 113. MC 1496/1596 and 189. MC 3361 and 1992. MC 3403 and 160. NE 5044 and 131. N 1311. N 1341. NE 5045 and 132. NE 5050 and 1951. NE 5080/5081 and 195. NE/SA/SE 51051A and 1161. N 1950. NE 5150/51152 and 1081. NE 521 and 116. NE 522 and 116. NE 5230 and 1511. N 1512. NE 527 and 116. NE 529 and 116. NE 531 and 1511. NE 542 and 190. NE 544 and 133. NE 5512/5514 and 144. and 144L. NE 5517 and 145. NE 5520 and 118. and 1180. NE 5521 and 1181. And 1182. NE 5532/33/34 and 142. NE 5539 and 140. NE 555 and 170. NE 556 and 170. NE/SE 5560 and 1211. and 122. and 1221. and 125. NE/SE 5561 and 123. and 124. and 125. NE/SE 5562 and 125. NE/SE 5568 and 125. December 1988. Application Notes. By part numbers. Applying the DAC08. Using the DAC08 without a negative supply. Using the MC1488/89 line drivers and receivers. Using the MC1488/89 line drivers and receivers. Balanced modulator ID modulator applications using the MC1496/1596. Using the Synutix MC3361 demonstration board. Applications for the MC3403. Applications using the NE5044 encoder. Low-cost aid conversion using the NE5044. Control system for home computer and robotics. Applications using the NE5045 decoder. NE5050, power line modem application board. Cookbook. Applications using the NE5080, NE5081. 12-bit aid converter using the NE5105 comparator. Exploring the possibilities in data communications. NE5150/51/52 family of video 01A converters. Applications for the NE521/522/527/529. Applications for the NE521/522/527/529. Low voltage gated generator, NE5230. All-in-one, NE5230. Applications for the NE521/522/527/529. Applications for the NE521/522/527/529. Low voltage gated generator, NE5230. Applications of low noise stereo amplifiers, NE542. Applications using the NE544 servo amplifier. Applications for the NE5512. Applications for the NE5514. NE5517, general description and applications for use with the NE5517/a transconductance amplifier. LVDT signal conditioner, applications using the NE5520. A microprocessor-based servo loop for linear position control. NE5521 in a modulated light source design. Application. NE5521 in multifaceted applications. Audio circuits using the NE5532/33/34. Compensation techniques for use with the SE/NE5539. NE555 and NE556 applications. NE555 and NE556 applications. A microprocessor controlled switched mode power supply. NE5560 push-pull regulator application. Switched mode drives for DC motors. Progress in SMPS magnetic component. Optimization. NE5561 applications. External synchronization for the NE5561. Progress in SMPS magnetic component. Optimization. Progress in SMPS magnetic component. Optimization. Progress in SMPS magnetic component. Optimization. 1 to 17. Vol 1, Vol 2, Vol 3. 5 to 90. 5 to 122. 5 to 29, 6 to 11. 5 to 29, 6 to 11. 4 to 61. 4 to 108. 4 to 58. 8 to 11. 8 to 13. 8 to 22. 8 to 21. 5 to 50. 5 to 86. 5 to 269. 5 to 94. 5 to 176, 11 to 26. 5 to 295. 5 to 295. 4 to 134. 4 to 136. 5 to 295. 5 to 295. 4 to 134. 7 to 135. 8 to 39. 4 to 91. 4 to 97. 4 to 276. 5 to 329. 5 to 344. 5 to 359. 5 to 363. 4 to 114. 4 to 32. 4 to 232. 11 to 81. 7 to 54. 7 to 54. 8 to 88. 8 to 94. 8 to 97. 8 to 250. 8 to 107. 8 to 112. 8 to 250. 8 to 250. 8 to 250. Synutix linear products. Application notes by part numbers. Vol 1, Vol 2, Vol 3. NE/SLSE 5570 and 1281. NE 5570 A Theory of Operation and Applications 8 to 49. NE 558 and 171. NE 558 Applications 7 to 43. NE 564 and 179 Circuit Desktop of the NE 564 4 to 252. And 180. The NE 564, Frequency Synthesis 4 to 259. And 1801, 108 MHz FSK decoder with the NE 564 4 to 263. And 181, a 6 MHz FSK converter design example for the NE 564 4 to 266. NE 564 and 182. Clock regenerator with crystal controlled. Phase locked VCO 4 to 268. NE 565 and 183. Circuit description of the NE 565 4 to 283. And 184, FSK demodulator with NE 565 4 to 287. NE 566 and 185, circuit description of the NE 566 4 to 295. And 186 waveform generators with the NE 566 4 to 296. NE 567 and 187 circuit description of the NE 567 tone decoder 4 to 311. And 188. Selected circuits using the NES 67 4 to 316. NE 570/571/SA 571 and 174 applications for companders, NE 570/571/SA 571 4 to 325. NE 572 and 175 automatic level control, NE 572 4 to 356. NE 587/589 ANL12, LED decoder drivers, using the NE 587 and NE 589 6 to 72. NE 592/5592 and 141. Using the NE592/5592 video amplifier 4 to 53 4 to 253 11 to 102. NE/SA602 and 1981, new low-power single-sideband circuits, NE602, 4 to 72. In 1982, applying the oscillator of the NE602 in low power. Mixer applications 4 to 80. NE/SA604A in 1991, audio decibel level detector with meter driver 4 to 124 4 to 201. NE/SA604A in 1993 high sensitivity applications of low power RF/IV. Integrated circuits 4 to 126 4 to 203. PNA 7509 and 108, an amplifying, level shifting interface for the PNA 7509 video D/A converter 5 to 81 11 to 18. SAA 1057 and 196 single chip synthesizer for radio tuning 4 to 190. And 197. Analysis and basic application of the SAA 1057 4 to 197. SAA 3004 and 1731, SAA 3004, low power remote control IR. Transmitter and receiver preamplifiers 5 to 10. SAB 3035 and 157, microcomputer peripheral IC tunes and controls A. TV set 4 to 55. SG 1524C and 1261, high frequency femte power transformer and choke design 8 to 154. SG 3524C and 125, progress in SMPS magnetic component. Optimization 8 to 250. And 126, applications using the SG 3524 8 to 214. And 1261, high frequency femte power transformer and choke design 8 to 154. And 1262. Theory of operation and applications for SG 1524CI. 2524C/3524C 8 to 200. TDA 1013A and 148, audio amplifier with TDA 1013A 7 to 120. TDA 1023 and 1291, design of time proportional temperature controls 8 to 276. TDA 1072A and 1961, TDA 1072A, integrated AM receiver 7 to 15. TDA 1510 and 1491, car radio audio power amplifiers up to 24W with the TDA 1510 7 to 232. TDA 1515 and 1481, car radio audio power amplifiers up to 20W with the TDA 1515 7 to 252. TDA 1520A and 149, 20W Hi-Fi power amplifier with the TDA 1520A 7 to 264. TDA 2578 and 1621, directives for a print layout design on behalf of the IC combination TDA 2578A and TDA 3651 9 to 30. TDA 2595 and 158, features of the TDA 2595 synchronization processor 9 to 57. And 162, a versatile high-resolution monochrome data and graphics display unit 9 to 25. TDA 2653 and 162, a versatile high-resolution monochrome data and graphics display unit 9 to 25. TDA 3047 and 172, circuit description of the infrared receiver 5 to 50. And 173, low power preamplifiers for IR remote control. Systems 5 to 52. TDA 3048 and 172, circuit description of the infrared receiver 5 to 50. And 173, low power preamplifiers for IR remote control. Systems 5 to 52. December 1988 1 to 18. Syniotix Unier products. Application notes by part numbers. Vol 1, Vol 2, Vol 3. TDA 3505 UNI 55/A, multi-standard color decoder with picture. Improvement 10-3. TDA 3651 and 1621, directives for a print layout design on behalf of the IC combination TDA 2578A and TDA 3651 9-30. TDA 4555 UNI 55/A, multi-standard color decoder with picture. Improvement 10-3. N1551, single chip multi-standard color decoder TDA 45551. 4556 10-44. TDA 700192, a complete FM radio on a chip 7-46. N193, TDA 7000 for narrowband FM reception 7-61. TL 067 and 1942, TL 067, application of the low voltage versatile transmission circuit 6-125. N1943, TL 067, supply of peripheral circuits with the T1067 speech circuit 6-145. 1 law 758 and 191, stereo decoder applications using the JJ.A 758 7-123. December 1988 1-19. Syniotix. Linear products. December 1988. Volume 2. Industrial. Preface. Product status. Section 1, General information. Section 2, Quality and reliability. Section 3, 1-2C small area networks. Section 4, Amplifiers. Operational. High frequency. Transconductance. Fiber optics. Section 5, Data conversion. Analog to digital. Digital to analog. Comparators. Sample and hold. Position measurement. Section 6, Interface. Line drivers/receivers. Peripheral drivers. Display drivers. Serial to parallel converters. Section 7, Timers and clocks. Section 8, Power conversion/control. Section 9, System control. Section 10, Package information. Section 11, Sales offices. 1-20. Syniotix. Linear products. December 1988. Volume 3. Video. Preface. Product status. Section 1, General information. Section 2, Quality and reliability. Section 3, 1-2C small area networks. Section 4, Tuning systems. Tuner control peripherals. Tuning circuits. Prescalers. Tuner IC. Section 5, Remote control systems. Section 6, Television subsystems. Section 7, Video IF. Section 8, Sound IF and special audio processing. Section 9, Sync processing and generation. Section 10, Color decoding and encoding. Section 11, Special purpose video processing. Video modulator/demodulator. 8 converters. 0/A converters. Switching. High frequency amplifiers. CCD memory. Section 12, Vertical deflection. Section 13, Switched mode power supplies for TV/monitor. Section 14, Package information. Section 15, Sales offices. 1-21. Syniotix. Linear products. Manufacturer Syniotix. Manufacturer part number. AMD AM26LS30 PC AM26LS30 CN AM26LS31 PC AM26LS31 CN AM26LS32 PC AM26LS32 CN AM25LS33 PC AM26LS33 CN AM6012 DC AM6012F DACOBAQ DACOBAF DACOBCN DACOBCN DACOBCQ DACOBCF DACOBAN DACOBAN DACOBEQ DACOBEF DACOBHN DACOBHN DACOBHQ DACOBHF DAC08Q DACOBF LF198H LF198H LF19BH SE5537H LF398H LF39BH LF39BH NE5537H LF398 LF398D LF398 LNE5537D LF398N LF39BN LF39BN NE5537N Datal AM453-2 NE5534/AF AM453-2C NE5534/AF AM453-2 MSE5534/AF DAC up 10 BC NE5020N DAC up 8 BC NE5018N DAC up 8 BM SE5019F DAC up SE5018F XR558CN NE55BF XR558CP NES58N XR558M SE558F XRL567CN NE567F XRL567CP NE567N XR14BBCP MC148BN XR1489/ACP MC1489/N XR1524N SG3524F XR1524P SG3524N XR2524P SG3524N XR3524N SG3524F XR3524P SG3524N XR455BCP NE4558N XR5532/AN NE5532/AF XR5532/AP NE5532/N XR5534/ACN NE55341AF XR55341ACP NE55341N XR55341AM SE55341AF XR6118CP NE594N XR13600CP NE5517N Harris HA2539N NE5539N HA2420-2/8B SE5060F HA2425N NE5060N HA2425B NE5060F HA5320B NE5060F Cross-reference guide by manufacturer. Pin for pin functionally compatible star. Cross-reference by manufacturer. Temperature manufacturer Synutix temperature. Range, OC, package manufacturer part number range, OC, package. O2 plus 70 plastic high 5102-2 SE 5532/AF, 55 plus 125 ceramic. O2 plus 70 plastic high 5135-2 SE 5534/AF, 55 plus 125 ceramic. O2 plus 70 Plasl C high 5135-5 NE 5534/AF O2 plus 70 ceramic. O2 plus 70 plastic high 5202-5 NE 5532/AF O2 plus 70 ceramic. O2 plus 70 ceramic HA3-5102-5 NE 5532/and O2 plus 70 plastic. 55 plus 125 ceramic. O2 plus 70 plastic. O2 plus 70 ceramic. O2 plus 70 plastic. O2 plus 70 ceramic. O2 plus 70 plastic. O2 plus 70 ceramic. Intersil ADC0803 LCD ADC0803-1 LCF-42 plus 85 ceramic. ADCOA04 ADCOA04-1 CN02 plus 70 plastic. ADC0805 ADCOA05-1 LCN42 plus 85 plastic. ICM7555 CBA ICM7555 CDO2 plus 70 plastic. ICM75551 PA ICM75551 N-42 plus 85 plastic. ACM7555 CP ICM7555 CNO2 plus 70 plastic. -55 plus 125 ceramic Motorola AM26LS31 PCD AM26LS31 CDO2 plus 70 plastic. 55 plus 125 metal can AM26LS31 PC AM26LS31 CNO2 plus 70 plastic. 55 plus 125 metal can AM26LS32 PC AM26LS32 CNO2 plus 70 plastic. O2 plus 70 metal can AM26LS32 PCD AM26LS32 CDO2 plus 70 plastic. O2 plus 70 metal can DACOB CD DACOB CNO2 plus 70 plastic. O2 plus 70 plastic DACOB CQ DACOB CFO2 plus 70 ceramic. O2 plus 70 plastic DACOB DAC08 NO2 plus 70 plastic. O2 plus 70 plastic DACOBEF DACOBEF O2 plus 70 ceramic. O2 plus 70 plastic DACOBHQ DACOBHF O2 plus 70 ceramic. O2 plus 70 ceramic DACOBQ DAC08F, 55 plus 125 ceramic. O2 plus 70 ceramic. 55 plus 125 ceramic. O2 plus 70 plastic. O2 plus 70 plastic. 55 plus 125 ceramic. -55 to 125 ceramic. LM2901N LM2901N -42 plus B5 plastic. LM311J8 LM311F O2 plus 70 ceramic. LM311N LM311N O2 plus 70 plastic. LM324J LM324F O2 plus 70 ceramic. LM324N LM324N O2 plus 70 plastic. LM339/AJ LM339/AF O2 plus 70 ceramic. O2 plus 70 ceramic LM339/AN LM339/AN O2 plus 70 plastic. O2 plus 70 plastic LM35BN LM358N O2 plus 70 plastic. 55 plus 125 ceramic LM393A1J LM393/AF O2 plus 70 ceramic. O2 plus 70 ceramic LM393A1N LM393/and O2 plus 70 plastic. O2 plus 70 plastic MC1408 LMC1408F O2 plus 70 ceramic. O2 plus 70 plastic MC140BP MC1408N O2 plus 70 plastic. O2 plus 70 plastic MC14BB LMC14B8F O2 plus 70 ceramic. O2 plus 70 ceramic MC14B8P MC148B and O2 plus 70 plastic. O2 plus 70 plastic MC1489/AL MC14B9/AF O2 plus 70 ceramic. O2 plus 70 plastic MC14B9/AP MC14B9/ and O2 plus 70 plastic. O2 plus 70 ceramic MC1496L MC1496F O2 plus 70 ceramic. O2 plus 70 plastic MC1496P MC1496N O2 plus 70 plastic. O2 plus 70 plastic MC3302L MC3302F-42 plus B5 ceramic. O2 plus 70 ceramic MC3302P MC3302N-42 plus B5 plastic. O2 plus 70 plastic MC3361D MC3361D O2 plus 70 plastic. O2 plus 70 ceramic MC3361P MC3361N O2 plus 70 plastic. O2 plus 70 plastic MC3403L MC3403F O2 plus 70 ceramic. 55 to plus 125 ceramic MC3403P MC3403N O2 plus 70 plastic. O2 plus 70 plastic MC3410CL MC3410CF O2 plus 70 ceramic. O2 plus 70 plastic MC3410L MC341 of O2 plus 70 ceramic. O2 plus 70 plastic. 55 to plus 125 ceramic. O2 plus 70 plastic. O2 plus 70 ceramic. O2 plus 70 ceramic. NE5410F O2 plus 70 ceramic. MC3510L MC5410F, 55 to plus 125 ceramic. NE565N NE565N O2 plus 70 plastic. NE592F NE592F O2 plus 70 ceramic. NE592F NE592F 14 O2 plus 70 ceramic. NE592N NE592N 14 O2 plus 70 plastic. 1 to 22. Synthetix linear products. Cross-reference guide. Manufacturer slow Netlix temperature. Manufacturer Synthetix temperature. Manufacturer part number range, OC, package. Manufacturer part number range, OC, package. SE592F SE592F8, 55 to plus 125 ceramic LM565CN NE565N O2 plus 70 plastic. SE592F SE592F 14, 55 to plus 125 ceramic LM566N SE566N, 55 to plus 125 plastic. SE592H SE592H, 55 to plus 125 metalcan LM566CN NE566N O2 plus 70 plastic. LM567CN NE567N O2 plus 70 plastic. LM733CN1 La 733CN O2 plus 70 play suck. LM741CJ1 La 741CF O2 plus 70 ceramic. LM741CN ILA 741CN O2 plus 70 play suck. LM741J1 La 741F, 55 to plus 125 ceramic. LM741N ILA 74TN-55 to plus 125 plastic. LM747CJ1 La 747CF O2 plus 70 ceramic. LM747CN ILA 747CN O2 plus 70 play suck. LM747J1 L747F, 55 to plus 125 ceramic. LM747N ILA 747N-55 to plus 125 plastic. LMC 555 CN ICM 7555 CnO2 plus 70 plastic. LMC 555 CM ICM 7555 CdO2 plus 70 play suck. 1 La 080/DA DAC 08 FO2 plus 70 ceramic. 1 La 0801 CDC MC 1408 FO2 plus 70 ceramic. 1 La 0801 CPC MC 1408 NO2 plus 70 plastic. 1 La 0801 EDC DAC 08 FO2 plus 70 ceramic. 1 La 0801 EPC DAC 08 AFO2 plus 70 ceramic. 1 La 124 J2 M124 F-55 2 plus 125 ceramic. 1 La 1458 TC MC 1458 NO2 plus 70 play suck. 1 La 1488 DC MC 1488 FO2 plus 70 ceramic. National ADC 0803 FADC 08031 LCF 42 plus 85 ceramic. ADC 0803 NADC 08031 LCN 42 plus 85 play suck. ADC 0805 ADC 08051 LCN 42 plus 85 plastic. ADC 0820 CCN ADC 0820 CNEN 02 plus 70 play suck. ADC 0820 CCD ADC 0820 CSAN 42 plus 85 plastic. ADC 0820 CD ADC 0820 CSEF 55 2 plus 125 ceramic. DAC 0800 LCJ DAC 08 FO2 plus 70 ceramic. DAC 0800W DAC 08 F-55 2 plus 125 ceramic. DAC 0800 LCN DAC 08 NO2 plus 70 plastic. DAC 0801 LCJ DAC 08 CFO2 plus 70 ceramic. DAC 0801 LCN DAC 08 CNO2 plus 70 plastic. DAC 0802W DAC 08 AF-55 2 plus 125 ceramic. DAC 0802 LCJ DAC 08 HFO2 plus 70 ceramic. DAC 0802 LCN DAC 08 HNO2 plus 70 play suck. DAC 0806 LCJ MC 1408-6 FO2 plus 70 ceramic. DAC 0806 LCN MCI 4086 NO2 plus 70 play suck. DAC 0807 LCJ MC 14087 FO2 plus 70 ceramic. DAC 0807 LCN MC 14087 NO2 plus 70 play suck. DAC 0808 LCJ MC 1408 FO2 plus 70 ceramic. DAC 0808 LCN MC 1408 NO2 plus 70 plastic. 1 La 1488 PC MC 1488 NO2 plus 70 play suck. DAC 0808 LD MC 1408 FO2 plus 70 ceramic. 1 La 1489/A PC MC 1489/A FO2 plus 70 ceramic. DS 3691 NAM 26 LS 30 CNO2 plus 70 plastic. ILA 14891 APC MCI 4891 NO2 plus 70 plasn. DS 3691 MAM 26 LS 30 CDO2 plus 70 plasn. 1 La 198 NE 5537 HO2 plus 70 metal can. LF 198 HSE 5537H 55 2 plus 125 metal can. 1 La 198 RMNE 5537 NO2 plus 70 plastic. A2901 DC LM2901 F-42 plus 85 ceramic. A2901 PC LM2901 N-42 plus 85 plastic. 1 La 311 RC LM311 FO2 plus 70 ceramic. 1 La 324 DC LM324 FO2 plus 70 ceramic. 1 La 324 PC LM324 NO2 plus 70 plastic. 1 La 3302 DC MC3302 F-42 plus 85 ceramic. 1 La 3302 PC MC3302 N-42 plus 85 plastic. 1 La 339/ADC LM339/AFO2 plus 70 ceramic. 1 La 339/APC LM339/NO2 plus 70 plastic. 1 La 3403 DC MC3403 FO2 plus 70 ceramic. 1 La 3403 PC MC3403 NO2 plus 70 plastic. 1 La 398 HCSE 5537H-55 to plus 125 metal can. 1 La 398 RCSE 5537N-55 to plus 125 plastic. 1 La 555 TCNE 555 NO2 plus 70 plastic. 1 La 556 PCNE 556 1N, O2 plus 70 plastic. NE 556N. 1 La 723 DC 1 La 723 CFO2 plus 70 ceramic. 1 La 723 DM 1 La 723 F-55 to plus 125 ceramic. 1 La 723 PC 1 La 723 CNO2 plus 70 plastic. 1 La 733 DC 1 La 733 FO2 plus 70 ceramic. 1 La 733 DM 1 La 733 F, 55 to plus 125 ceramic. 1 La 733 PC 1 La 733 NO2 plus 70 plastic. 1 La 741 NM 1 La 741 N, 55 to plus 125 plastic. 1 La 741 RC 1 La 741 CFO2 plus 70 ceramic. 1 La 741 TC 1 La 741 CNO2 plus 70 plastic. 1 La 747 DC 1 La 747 CFO2 plus 70 ceramic. 1 La 747 PC 1 La 747 CNO2 plus 70 plastic. UC 3842 DUC 3842 DO2 plus 70 plastic. UC 3842 JUC 3842 FeO2 plus 70 ceramic. UC 3842 NUC 3842 NO2 plus 70 plastic. UC 2842 DUC 2842 DO2 plus 70 plastic. UC 2842 JUC 2842 FeO2 plus 70 ceramic. UC 2842 NUC 2842 NO2 plus 70 plastic. LF 398 HNE 5537 HO2 plus 70 metal can. LF 398 NNE 5537 NO2 plus 70 plastic. LM 13600 and NE 5517 NO2 plus 70 plasn. LMI 3600 and NE 5517 NO2 plus 70 plastic. LM 1458 and MC 1458 NO2 plus 70 plastic. LM 161 HSE 529 H-55 to plus 125 metal can. LM 161 JSE 529 F-55 to plus 125 ceramic. LM 2524 JSG 3524 FO2 plus 70 ceramic. LM 2524 NSG 3524 NO2 plus 70 playsuck. LM 2901 N LM 2901 N-42 plus 85 plastic. LM 2903 N LM 2903 N-42 plus 85 plastic. LM 3089 CA 3089 N, 55 to plus 125 plastic. LM 319 J LM 319 FO2 plus 70 ceramic. LM 319 N LM 319 NO2 plus 70 plastic. LM324J LM324FO2 plus 70 ceramic. LM324N LM324NO2 plus 70 plastic. LM324AD LM324ADO2 plus 70 plastic. LM324 and LM324NO2 plus 70 plastic. LM339/AJ LM339/AFO2 plus 70 ceramic. LM339/and LM339/NO2 plus 70 plastic. LM3524J SG3524FO2 plus 70 ceramic. LM3524N SG3524NO2 plus 70 plastic. LM358H LM358HO2 plus 70 metal can. LM358N LM358NO2 plus 70 plastic. LM361H NE529HO2 plus 70 metal can. LM361J NE529DO2 plus 70. LM361N NE529NO2 plus 70 plastic. LM393/and LM393/NO2 plus 70 plastic. LM555J NE555FO2 plus 70 ceramic. LM555N NE555NO2 plus 70 plastic. LM556J SE556-1F-55 plus 125 ceramic. LM556N SE556-1N-55 plus 125 plastic. LM556CJ NE556-1FO2 plus 70 ceramic. LM556CN NE556-1NO2 plus 70 plastic. 1 to 23. Synthetix Unier products. Cross-reference guide. Manufacturer Synthetix temperature. Manufacturer part number range, OC, package. UC1842J UC1842 Fe-55 to plus 125 ceramic. UCI842 and UC1842 N-55 to plus 125 plastic. NECIIPC1571C NE571 NO2 plus 70 plastic. PMICMP05GP NE5105 NO2 plus 70 plastic. CMP05CZ SE5105F-55 to plus 125 ceramic. CMP05BZ SE5105F, 55 to plus 125 ceramic. CMP05GZ SA5105N-40 to plus 85 plastic. CMP05FZ SA5105N-40 to plus 85 plastic. DACI408A6 PMC1408-6 NO2 plus 70 plastic. DACI408A SQMC1408-6 FO2 plus 70 ceramic. DACI408A7 NMC14087 NO2 plus 70 plastic. DACI408A7 QMC14087 FO2 plus 70 ceramic. DACI408A8 NMC14088 NO2 plus 70 plastic. DACI408A8 QMC1408-8 FO2 plus 70 ceramic. DACI508A8 QMC1408-8 F-55 to plus 125 ceramic. DAC312FRAMS012 FO2 plus 70 ceramic. OP27BZ SE5534AFE, 55 to plus 125 ceramic. OP27CZ SE5534 Fe-55 to plus 125 ceramic. PM747Y1 La 747 N-55 to plus 125 plastic. SMPL0I SE50 S0F, 55 to plus 125 ceramic. SMPL0EY NE50 S0 NO2 plus 70 plastic. SMPLLAY SE5060 F-55 to plus 125 ceramic. SMPLLEY NE50 S0 N Odo plus 70 plastic. Raytheon RC4805 to NE5105 N Odo plus 70 plastic. RC4805 A to NE5105 and O2 plus 70 plastic. RM4805 to SE5105 F-55 to plus 125 ceramic. RM4805 A to SE5105 AF-55 to plus 125 ceramic. RC5532 A to NE5532 AFO2 plus 70 ceramic. RC5532 ANB NE5532 Odo plus 70 plastic. RC5534 A to NE5534 AFO2 plus 70 ceramic. RC5534 ANB NE5534 O2 plus 70 plastic. RM5532 A to SE5532 AF-55 to plus 125 ceramic. RM5534 A to SE5534 AF-55 to plus 125 ceramic. Silicon SG3524J SG3524 FO2 plus 70 ceramic. General SG352 SN SG3526 NO2 plus 70 plastic. Sprague UDNS 118A SA594 N-42 plus 85 plastic. UDNS 118 RSA 594 F-42 plus 85 ceramic. ULN 3524 ASG 3524 O2 plus 70 plastic. ULN 8142 MUC 3842 NO2 plus 70 plastic. ULN 8160 ANE 5560 NO2 plus 70 plastic. ULN 8160 RNE 55 S0 FO2 plus 70 ceramic. ULN 8161 MNE 5561 NO2 plus 70 plastic. ULN 8168 MNE 5568 NO2 plus 70 plastic. ULN 8564 ANE 564 NO2 plus 70 plastic. ULN 8564 RNE 564 FO2 plus 70 ceramic. ULS 8564 RSE 564 F-55 to plus 125 ceramic. TIADC 0803 NADC 0803 1LCN 42 plus 85 plastic. ADC 0804 CN ADC 08041 CN 02 plus 70 plastic. ADC 0805 NADC 08051 LCN 42 plus 85 plastic. LMLLLJ LMLLLF-55 to plus 125 ceramic. Manufacturer Cignatics temperature. Manufacturer part number range, OC, package. LM311D LM311D O2 plus 70 plastic. LM311J LM311F O2 plus 70 ceramic. LM311JG LM311Fe O2 plus 70 ceramic. LM324D LM324N O2 plus 70 plastic. LM324J LM324F O2 plus 70 ceramic. LM339, AJ LM339/AF O2 plus 70 ceramic. LM339/and LM339/and O2 plus 70 plastic. LM358P LM358N O2 plus 70 plastic. LM393/AP LM393/and O2 plus 70 plastic. MC1458P MC1458N O2 plus 70 plastic. NE55321AJG NE55321AF O2 plus 70 ceramic. NE5532/AP NE5532/NO2 plus 70 plastic. NE55341AJG NE55341AFO2 plus 70 ceramic. NE5534/AP NE5534/NO2 plus 70 plastic. NE555JG NE555NO2 plus 70 plastic. NE555P NE555NO2 plus 70 plastic. NE556P NE556NO2 plus 70 plastic. NE556J NE556-1FO2 plus 70 ceramic. NE55SN NE55S1NO2 plus 70 plastic. NE592 NE592N14O2 plus 70 plastic. NE592A NE592F14O2 plus 70 ceramic. NE592J NE592FO2 plus 70 ceramic. NE592N NE592N14O2 plus 70 plastic. SA556P SA556N-42 plus 85 plastic. SE55341AJG SE5534. AF-55 plus 125 ceramic. SE555JG SE555N-55 plus 125 plastic. SE55SJ SE55S1F-55 plus 125 ceramic. SE55SN SE556-1N-55 plus 125 plastic. SE592 SE592N14-55 plus 125 plastic. SE592J SE592F14-55 plus 125 ceramic. SE592N SE592N14-55 plus 125 plastic. SN55107AJ NE521F0 plus 70 plastic. SN55108AJ SE522F-55 plus 125 ceramic. SN751007AJ NE521F0 plus 70 plastic. SN751007 and NE521N0 plus 70 plastic. SN751008AJ NE522F02 plus 70 ceramic. SN751008 and NE522N0 plus 70 plastic. SN75186J MCI488F02 plus 70 ceramic. SN75188 N MCI468N02 plus 70 plastic. SN75189AJ MC1489AF02 plus 70 ceramic. SN75189 and MCI489 and O2 plus 70 plastic. SN75189J MC1489F02 plus 70 ceramic. SN75189 N MCI489A02 plus 70 plastic. TL592A NE592F14O2 plus 70 ceramic. TL592P NE592NB02 plus 70 plastic. 1 La 723CJ 1 La 723CF02 plus 70 ceramic. 1 La 723CN 1 La 723CNO2 plus 70 plastic. 1 La 723MJ 1 La 723F 55 to plus 125 ceramic. Uneldrikta UC 3524 JSG 3524 FO2 plus 70 ceramic. UC 3524 NSG 3524 NO2 plus 70 plastic. There may be parametric differences between Signetics parts and those of the competition. 1 to 24. Cross-reference guide by numeric usting. Numeric description Slow Netlix Analog EXAR Fairchild Hitachilware Motorola National NA PM. Ray RCASGS/Silicon Sprague TIO1 LIEAS devices. Tech Thien Thomson General. Q. Koj 0 N DACOIIBBI IDEA IJAC.08 F ADAC 08 PA 080 IDAHA 17008 DAC 08 DAC 0800 PLC 624 DAC 08 Datal IJAC.08 NC J Co DAC 08 AF PAL 80 LE DAC 0801 AMD IJAC.08 DAC 08 CF CNDAC 0802 HAMS High 5618 NE 5007F N DAC 08 ED N NE 5008D FN SE 5008F DAC OIF HN NE 5009F N SE 5009F 0803182 8 ADC 0803 LCF LCN ADC 0803 ADC 0803 Antar SLL 1 Q CD1J CDAA I C0 J T 0 CD 08041 Converter ADC 0804 CN LCD ADC 0804 ADC 0804 ADC 0803 0805 LCF LCN ADC 0805 ADC 0805 0840 ADC 0805 LCN OB05 0620B.8 GCMOS ADCOB 20 CNED AD7B20 ADCOB 20 MM J C A Aldeo ADC 0820 CNEN MaxL 50 CD 3 Voy 1 Age LM111 Fe ADTTT 111 L.ML11 LM111 LML11 Myinski LML11 Comparalove 119 Dual LM119 FLTI19 LMI19 PMI19 Comparalore LMI19Z 124 Quad Op Amp LM124F NLM124 LT1014 LMI24 LMI24 CAI24 SGI24 LM124C 13600 High NE5517 and XRI 3600 LMI 3800 IA Performance Dual T Ranskin NE5517D N 3 CD U1 Amp 139 Quad LMI 39 AF 139 LMI 39 LMI 39 PMI 39 LM139 CA 139 LMI 39 Comparator LMI 39F and CMP 4 CR C: 14081 8-811D/AMCI 408 NADI 40B 080 ICHA 17408 MCI 4081 DECOB 8 DAC 140B DAC 1408 HAMS 1508 Converter MCI 40B 7F and 1508 0807 High 5618 MCI 408.AOF and 080B MCI 50B 8F N R HAMS MC 1458D and CM 1458 14581 Dual Op Amp MC 1558N 1458 MCI 45B LMI 45B PC 251 Op 14 CA 1458 MCI 458 MCI 45B Samsung 1558 MCI 558 LMI 558 MC 1458 SA 145BN Micro Power MP Op 14 1488 quad line MCI 48 SD, F, NXRI 488. 1488 MCI 488 051488 MC 1488 SN 75188. Denver MCI 488. 1489. Quadline MCI 4B9A. DFNXRI 4B91. 14891A MCI 4891A DS14B9IA MCI 489 SGI 4891A SN 75189/A. Reesjaver MCI 4S9D. FNA MC 1489/A. 14961 Balanced MCI 496F. NMC 1496L.M 1496 PTC Modulator. 796 SGI 496 1596. Demodulator MC 1596F. NMCI 596 LMI 596 SL 1496. Cherry. 1524. Improved SMPS. 5G 1524 CF. CNXRI 524 LTI 524 CA 1524 SG 1524 SG 1524 ULNB 124 SG 1524 CS 1524. Control Circuit Umtrode. UC 1524. 158 Dual Op Amp LMI 58 Fe. NLMI 58 LMI 58 LM15B LM15B Intel SLL. NE 532 Fe. NCA 158. 193 Dual Cold 1W8 Tor LMI 93 AFE. 193 LMI 93 IA LMI 931A LMI 931A. 1_193 Fe, L__. Cross-reference guide by numeric listing, continued. NUIIEIFC description Succinctix analog EXAR Fairchild Hitachi Unir Motorola National NEC Pili Ethio RCA SGSISLUCON Sprague and others eVices. Tech Thomson General. 5, J. A. N. G. AMO NC, J. 198. San IEN. LFI 98 Fe, H.98. LFI 98 LF 100 LF 198. AMP SE 5537 Fe, H Hams. HA 2430. 211. Voltage LM 211D. Fe. NAD 211 LM 211 LM 211 PM 211 SG 211 LM 211. Compifator. 219 iJoule co_LM 2190, F, NLM 219 TO 0119. 0. A. Q. CDU. CD8. J, C. J. A. 224 quad op amp. LE 224D. FNJLA 224 HA 17224 LM 224 LM 224 LM 224 LM 224. SA 534D. FN. N. CD. 239. Quad voltage LM 239 and JLA 239 LM 239 LM 23 L1 PM 239 LM 239 CA 239 LM 239. Co_. LM 239F. NCMP 04, J. Chani. 2524. Improved SMPS. SG 2524 CN SG 2524. CS 2524. Coniro IIC Unretrode. UC 2524. C. A. CD. 258 Dua IOP amp. LM258 NJLA258 HA17258 LM258 LM258.PC2580058 LM258 LM258 SA532A N 25 NSYNC W11H Vert OSC TDA 2577 ATDA 2577 and Unverzi 2593 Horizontal TDA 2593 TDA 2593 P. Comabanta 2593 C. 3. 28 LS31 Quad HR Speed AM28 LS31 AM28 LS31 AM28 LS31 DS28 LS31 AM28 LS31 AMO Medinvar CD CN IN MN AM25 LS31 2901 Quad Voltage LM2901D FNG 2901 LM2901 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 Comparator CD 0 2902 Quad Op Amp LM2902D Angia 2902 LM2902 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 SA534D FN 2903 Dual Voltage LM29/L3D Fe NPA 2903 LM2903 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 Comparator 3 S Q 2904 Dual Op Amp LM2904D Angia 2904 LM2904 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 293 Dual Comparator LM293 AFE and LM293/A 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 LM293 Fe N 3089 FM if system CA3089 NLM3089 311 voltage comparator 00110 Fe NJLA 311 00110 LM311 319 High speed LM319D FN LM319.PE 319 Dual Co 324 Quad Op Amp LM324AD and JLA324 HA17324 LM324/A LM324/A LM324 LM324 Samsung 00240 FN LM324 3302 Quad Voltage MC3302D FNGO 3303 MC3302 Comparator 3303 Quad Op Amp MC3300F Angio 3303 MC3303 MC3303 M3303 3381 Low Power FM if MC3381D and MC3381 SAM MC3361 339 Quad Voltage LM339AF and JLA339 LM339/A LM339/A.PC339 PM339 LM339 CA339 LM339 LM339 Comparator LM339D FN 34031 Quad Op Amp MC3403D FN_03 MC3403 RM4137 MC3403 MC3403 3503 MC3505 FN MC3503 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 _ N. Cross-reference guide by numeric listing, continued. Numeric description Synthetix Analog EXAR Fairchild Hitachi Linear Motorola National NEC PMI Radio RCA SGSI Silicon Sprague TI Others. Devices Tech Thomson General 5 equals 0 G N 3410110-81 /D/AMC 3410 FMC 3410 CHAMS MC 3410 CF 3510 Converter MC 3510 FME 3S10 High S6 ID Cherry 3524 SMPS Control 8G35240 F NXR 3524 LT 3524 LM 3524 CA 3524 8G 3524 8G 3524 ULN 3524 8G 3524 C83524 CLFC ULT Road UC 3524 3524C Improved SMPS 8G 3524C, D, N8G 35248. Unroad. Control Circuli UC 3524A. NC. Equals. C. CD1J. A. CD0. C. CD at. J. CD. 3526 SMPS SG 3526F, N8G 3526 8G 3526 ULN 8126. Umtrode. UC 3526, J. LM 358 AD, and Sanio. 358 Dual Up Amp LM 358D, NHA 17358 LM358/A LM358/A/LPC 358 up to 21 CA 358/A LM358 LM35B/LA 6358 NE 5320 N C 0 361 C 529 CD Umtrode 3842 SMPS UC 3842N, DUC 3842 and SG 3842M. UC 3842N/D. IE Cherry 0. 387 C 542. C. LM393 AFE, and 393 Dual Comparator. LM3930, NHA 17393 LM393/A LM393/A LM393 LM393/Asanio. LM393 Faisal LA 6393. 3. CD. R/:. Source. AMD. 0. J. 398 Sample and hold. LF398D, Fe, H, N. PA 398 LF398 LF398 SMPL0. LF398. AMP NE 5537D, Fe, H, N Hams. C. N. HA 2425. Dual General NE 45580, Fe, N. 4558. Purpose Op Amp. SA 4558 Fe, NXR 4588 MC 4558 RC 4558. SE 4558 Fe, N. Dash plus R. Q. 5007 COAC08C. 5008 CDAC08E. 5009 COAC08H. AMD. 5018 8BRT converter. NE5018D, F, NA.M6081. Voltage out SE5018F datal. DAC-PP8B. 8-bit D/ADAL-L. 5019 converter. NE5019F, and DAC. Voltage out. SE5019F PP8BM. 10 BLTD/ADAL. 5020 converter NE5020F, NIOAC PPL0. Voltage out. High-speed hams. 5060 precision NE5060 FAD583. SMPL0 Hot 2420. Sample SMPL1 Hot 2425. And hold amp Ha 5320. High speed. NE51050, N. I. SA5105 N. 5105 precision, NE510 SAL, CMP05 RCA805. Comparator. IANSWA source. Cross-reference guide by numeric listing, continued. Numeric description SLGNETICS. Analog. EXAR Fairchild Hitachi. Linear. Motorola National NECPMI ITHEC RCA. SGSI Silicon. Sprague TI Others Devices Tech. Thomson General. N. CoJ. A, and pound L. 8BIID/ANE5118F, and datal. 5118 converter. Current cut SE5118F. DAC up. 5170 octalan Denver NE5170A, N. Umtrode. UC5170. 5180 octal line NE5180A, N. Uneltrode. Receiver UC5180. And C. J. C. 8. A dash. Q. C. J. 529. HH speed NE529D, F, H, NLM161. Comparator SE529F, HLM361. 0. 531 high slew rate up NES 31 Fe, H, NAC 4531. Hams. AMPA 2515, J. 532 C 358. 542. Low noise dual NE542 NLM387. Preamp. C. A. 5517 C 13600. Dual low noise up. NE5532 AFE, and XR5532 hams. 5532 NE5532D, Fe, NRC55321A NE5532/A amp. SE5532 AFE, Fe. AHA 35102-5. Z. N. CD. 5533. Dual low noise up NE5533 N. XR5533 NE5533/A. AMP NE5533D, N. NE5534AD, and analog. NE5534 AFE Sol Systems. Source, MA 332. 5534 low noise up amp. NE5534D, Fe, N. XR5534 up 27 RC5534 IA NE5534/A datal SA5534AD, N. AM453-2C. SA5534N hams. SE5534AFE, and HA 5101/11. SE5534 Fe, N. C. 3. 0. R. Sig. R. 5537 C398, Q. 5539 Fast Op Amp. NE 5539D, F, NAD 5539 Hams. SE 5539, F, HHA 2539. NE 555D, Fe, NE 555 Inter SL1. 555 Timer SA 555D, NXR 555 PA 555 HA 17555 MC 1455 LM 555 PPC 555 RC 555 CA 555 NE 555 NE 555 NE 555 SE 555 CN, Fe, N. NE 556D, F, NE 556 Samsung. 556 Dual Timer SA 556 NPA 556 MC 1456 LM 556 NE 556 NE 556 NE 556 SE 556 CN, F, N. Cherry. 5580. SMPS Control NE 5560D, F, NUL N8160CS 5560C. Circuit SE 5560F, and Disk IPS Disk. IP 5560C. CH New York. 5561. SMPS Control NE 5561D, Fe, NUL N8161CS 5561. Circuit SE 5561 Fe, N DLSC IPS Disk. IP 5561C. Cherry. SMPS Control NE 5568D, NUL N8168CS 5588 5568. CLFCT.UT DLSC IPS DLSC. IP 5568C. Cross-reference guide by numeric listing, continued. Numeric description Synthetix Analog EXAR Fairchild Hitachi. Linear. Motorola National NECPMI Radio RCA SGSI Silicon Sprague TI Others. Devices Tech Thomson General. Co-OJ. N. NE558D, F, NNC, OJ. 558 Quad Timer SA558 NXR558. SE558F, N. High Frequency NE564N. 564, NE564D, F Sol N8564 Phase Locked Loop. Source. 565 Phase Locked Loop. NE565D, F, N. NE565 LM565 SE565F, N. 0. Q. Backslash. U. A. Backslash, Q. C. Backslash, 0. JIT. 566 Function Generator NE566D, F, NLM566. SE566F, N. Backslash. NE567D, F, Fe, NMCE, J. 567 Tone Decoder SE567 Fe, F, NXR567 LMS67 MCE567. Phase Locked Loop, SES67D Sol XR2567 Samsung. Source, LM567. C. 0. NE571D, F, N. Backslash. 571 Comp-Ender, SA571D, F, N Sol ILPC 1571C. Source. 583 C 5060. 0. F14, FA, H, HD14, C. HDB, HN14, HNS, NE592 Intersil. 592 Video Amplifier N14, NBILA592C NE592 LM592 TL592 NE592. SA592D8, N8. 3. \n. SES92 F14, F8, H. N14, N8. NES94D, F, and Sanio. 594 Vacuum Fluorescent, SA594D, F, NXR6118 ULN6188 LB1290. Display Driver SES94F, and Toshiba. T062781. CR. R. E. 5. AM6012F. AMD. 6012 BLT. D/A. AM6012D Sol XR3464 NSB464 OAC312. AM6012. Converter Harn Source. High 562A. Q. 6081 C5018. 6456 1 GHz Prescaler SAB 6456 PN, 2. Siemens. S04211. Precision MA 723 Co, CF, CNRC 723 CA 723 Inter SL1. 723 voltage MA 723F, and MA 723 HAL 7723 MC 1723 LM 723 LM 723 LM 723 LM 723 SG 723. A 723 LM 723. Regulator SA 723 CN. Differential MA 733 CF, CN Intersl. 733 Video PA 733 HAL 7733 MC 1733 LM 733 11A 733. AMP. .UA 733F, and .UA 733. Melcro Power. MA 741 CD, CFE, CN. MPOP02. General Purpose Plessy 741. Op-amp. UA 741 Fe, and MA 741 HAL 7741 MC 1741 LM 741 OP02 LM 741 SG 741 MA 741 SL 562. SA 741 CFE, CN Samsung. LM 741. --. Cross-reference guide by numeric listing, continued. New _IC description Synotics. Analog EXAR Fairchild Hitachi Linear Motorola NNO NAL NEC PMI ITHEC RCA SGS Isocon. Sprague NCLTHERS Devices Tech Thomson General. AN. 1 La 747 Co, CF, and 0-04M_. 747 Dual Op Amp 1 La 747F, and 1 La 747 Ha 17747 MC 1747 LM 747 JLLC 1418 PM 747 RC 747 CA 747 1 La 747 MPOP 04. SA 747 CN. 75188 C 1488. 75189 C 1499. CMOs. ICM 7555 CN, Co-Interso. 7555 ICM 75551N, 10 LMC 555 TLC 555 NMER. ICM 7555 MN. 1 cm 7555. NC. J. AJ, I. CDU. CDAC. CD. C. 0. J3. N. 7820 C0820 CD. 8126 C3526, J. 8160 C5560 C. 8161 C5551. C. 8188 C5588 CD. 8464 C6012. 8564 C564. Z. C. 3. CD. I. L. N. OR. In. S. Co. Synutix So availability list. Linear products. Part SMD. Description. Number package. Part SMD. Description. Number package. ADC0820D Sol 28-bit CMOS 8 NE532D So 8 dual op amp. DAC08 EDSO 16 8-bit DIA converter NE544D Sol 16 servo amp. LF398D So 14 sample and hold amp NE5512D So 8 dual high perf op amp. LM1870D Sol 20 stereo demodulator NE5514D Sol 16 quad high perf op amp. LM2901D So 14 quad volt comparator NE5517D So 16 dual high perf amp. LM2903D So 8 dual volt comparator NE5520D Sol 16 LVDT signal condominium CKT. LM311D So 8 voltage comparator NE5532D Sol 16 dual low noise up. LM319D So 14 high speed dual amp. Comparator NE5533D Sol 16 low noise up amp. LM324AD So 14 quad up amp NE5534AD So 8 low noise up amp. LM324D So 14 quad up amp NE5534D So 8 low noise up amp. LM339D So 14 quad volt comparator NE5537D So 14 sample and hold amp. LM358AD So 8 dual op amp NE5539D So 14 high frequency amp. LM358D So 8 dual op amp oldie bond. LM393D So 8 dual comparator NE555D So 8 single timer. MC1408-8D. So 16 8-bit DIA converter NE556D So 14 dual timer. MC1458D So 8 dual op amp NE5560D So 16 SMPS control CKT. MC1488D So 14 quad line driver NE5561D So 8 SMPS control CKT. MC1489D So 14 quad line receiver NE5562D Sol 20 SMPS control CKT. MC1489AD So 14 quad line receiver NE5568D So 8 SMPS control CKT. MC3302D So 14 quad volt comparator NE558D Sol 16 quad timer. MC3361D Sol 16 low power FM if NE5592D So 14 dual video amp. MC3403D So 14 quad low power op NE564D So 16 high frequency PLL. Amp NE565D So 14 phase locked loop. NE4558D So 8 dual op amp NE566D So 8 function generator. NE5018D Sol 24 8-bit DIA converter NE567D So 8 tone decoder PLL. NE5019D Sol 24 8-bit DIA converter NE568D Sol 20 PLL. NE5036D SO 14 6-bit 8 converter NE571D SOL 16 comp ender NE5037D SO 16 6BIL8 converter NE572D SOL 16 prog comp ender NE5044D SO 16 prog 7 channel NE587D SOL 27 sec LED driver encoder anode NE5045D SO 16 7 channel decoder NE589D SOL 27 sec LED driver NE5090D SOL 16 address relay driver cath NE5105/AD SO 8 high-speed NE5900D SOL 16 call progress decoder comparator NE592D 14 SO 14 video amp NE5170 APLCC 28 octal line driver NE592D 8 SO 8 video amp NE5180 APLCC 28 octal line receiver NE592 HD 14 SO 14 high gain video amp NE5204D SO 8 high frequency amp NE592 HD 8 SO 8 high gain video amp NE5205D SO 8 high frequency amp NE594D SOL 20 VAC or DISP driver NE521D SO 14 high speed dual NE602D SO 8 double BAL MEL SERL comparator oscillator NE5212D 8 SO 8 transmittance NE604D SO 16 low power FMIV amplifier system NE522D SO 14 high-speed dual NE605 SOL 20 FMIV system comparator NE612D SO 8 double balanced NE5230D SO 8 low voltage op amp mixer / oscillator NE527D SO 14 high-speed NE614D SO 16 low power FMIV comparator system NE529D SO 14 high-speed PCD 3311TD SO 16 DTMF / melody comparator generator February 1987 1-31 Synthetix linear products SO availability list Part SMD Description Number package Part SMD Description Number package PCD 3312TD SO 8 DTMF / melody SAA 3004 TD SOL 20 R/C transmitter generator with ICC SG 3524D SO 16 SMPS control circuit PCD 3315TD SOL 28 repertory pulse dial TDA 1001B TD SO 16 noise suppressor PCD 3360TD SO 16 progress tone ringer TDA 1005 ATD SO 16 stereo decoder PCF 2100TD SOL 28 LCD duplex driver TDA 3047 TD SO 16 IR preamp 40 TDA 3048 TD SO 16 IR preamp PCF 2111 TD VSO 40 LCD duplex driver TDA 5040 TD SO 8 brushless DC motor 64 driver PCF 2112 TD VSO 40 LCD duplex driver TDA 7010 TD SO 16 FM radio circuit 32 TDA 7050 TD SO 8 mono / stereo amp PCF 8570 TD SO 8 static RAM, 256x8, TDD 1742 TD SOL 28 frequency synthesizer. PCF 8571 TD SO 8 1K serial RAM ULN 2003 D SO 16 transistor array. PCF 8573 TD SO 16 clock / timer ULN 2004 D SO 16 transistor array. PCF 8574 TD SO 16 remote I/O expander ILA 723 CD SO 14 voltage regulator. PCF 8576 TD VSO 56 MUX / static driver ILA 741 CD SO 8 single op amp. PCF8577 TDVS 04032-64 segment LCD ILA 747 CD SO 14 dual op amp. Driver SA5105/AD SO 8 high speed. Comparator. Note. Asterisk non-standard pinout. SA5230D SO 8 low voltage op amp. SA5212D8 SO 8 transimpedance amp. SA532D SO 8 dual op amp. SA534D SO 14 dual op amp. SA555D SO 8 single timer. SA571D SOL 16 comp ender. SA572D SOL 16 comp ender. SA594D SOL 20 VACFLU or DISP driver. SA602D SO 8 double BAL mixer / oscillator. SA604D SO 16 lower power FMIV. System. Note. For information regarding additional SO products released since the publication of this document, contact your local Syniotix sales office. February 1987 1-32. Syniotix. Linear products. Ordering information. For prefixes ADC, AM, O, CA, DAC, ICM, LF, LM, MC, NE, SA, SE, SG, I1A, UC. Signetix Linear Integrated Circuit Prod Table 1 _ part number description. UX may be ordered by contacting either the local Syniotix sales office, Syniotix representatives and /or Syniotix Auto RIS distributors. A complete listing is located in the back of this manual. Minimum factory order. Commercial product. $1,000 per order. $250 per line item per order. Military product. $250 per line item per order. Table 1 provides part number information concerning Syniotix originated products. Table 2 is a cross-reference of both the old and new package suffixes for all presently existing types, while tables 3 and 4 provide appropriate explanations on the various prefixes employed in the part number descriptions. As noted in table 3, Syniotix defines device operating temperature range by the appropriate prefix. It should be not ed, however, that an SE prefix, -55 degrees Celsius to +125 degrees Celsius, indicates only the operating temperature range of a device and not its military qualification status. The military qualification status of any linear product can be determined by either looking in the military data manual and / or contacting your local sales office. December 1988. Part number. Cross-ref product. Part no. Family description. E, 51, LF398 Lin. C. Description of product function. _linear product family. Package descriptions, see table 2. Device number. Device family and temperature range prefix, see tables 3 and 4. 1-33. Syniotix linear products. Ordering information. Table 2. Package descriptions. Old new. Package. Description. A. AN14 lead plastic dip. AN14 lead plastic dip. Selected analog. Products only. B. BAN16 lead plastic dip. D. Micro miniature. Package, so. FF14, 16, 18, 22. and 24 lead. Ceramic dip. Cerdip. IACI 14, 16, 18, 22, 28, and 4 lead. Ceramic dip. KH10 lead T0-100. LH10 lead high profile. To 100 can. NA, NXN 24 lead plastic dip P. Q, RQ10, 14, 16, and 24 lead ceramic. Flat. T, TA H8 lead to 99. UUSIP plastic power. VN8 lead plastic dip. XAN18 lead plastic dip P. XCN20 lead plastic dip. XCN22 lead plastic dip P. XL, XFN28 lead plastic dip. A PLCC. EC246 header. Fe8 lead ceramic dip. December 1988. Table 3. Syntactics prefix and device temperature. Prefix. Device temperature. Range. NE02 plus 70C. SE-55C to plus 125C. SA-40C to plus 85C. Table 4. Industry standard prefix. Prefix device family. ADC linear industry standard. AM linear industry standard. CA linear industry standard. DAC linear industry standard. ICM linear industry standard. LF linear industry standard. LM linear industry standard. MC linear industry standard. NE linear industry standard. SA linear industry standard. SE linear industry standard. SG linear industry standard. P.A linear industry standard. UC linear industry standard. 1 to 34. Syntactics. Linear products. Syntactics integrated circuit products. May be ordered by contacting either the LAKI Syntactics Sales Office, Syntactics Representatives and /or Syntactics Auto RIS distributors. Minimum factory order. Commercial product. $1,000 per order. $250 per line item per order. Table 1 provides part number information concerning Syntactics/Philips INTE. Graded circuits. Table 2 provides package suffixes and descriptions for all presently existing types. Letters following the device number BR, LQ used in Table 2 are considered to be part of the device number. Table 3 provides explanations on the various prefixes employed in the part number descriptions. As noted in Table 3, Syntactics/Philips device operating temperature is defined by the appropriate prefix. Operating temperature. The third letter of the prefix, in a 3-letter prefix, is the temperature designator. The letters A to F give information about the operating temperature. A. Temperature range not specified. See datasheet. E.g. TDA 2541N. B. 0 to plus 70 degrees C. E.g. PCB 8573 PN. C. minus 55 degrees Celsius to plus 125 degrees Celsius. E.g. PCC 2111 PN. D. minus 25 degrees Celsius to plus 70 degrees Celsius. E.g. PCD 8571 PN. E. minus 25 degrees Celsius to plus 85 degrees C. E.g. PCE 2111 PN. F. minus 40 degrees Celsius to plus 85 degrees Celsius. E.g. PCF 2111 PN. December 19B8. Ordering information. For prefixes he, om, pc, pn, sa, 2, te. Table 1 underscore part number description. Part. Number. Product. Family. Product. Description. T0A2541 NLIN video if amplifier. 1. L. L description of. Product function. Product family linear. Package description, see table 2A. Underscore dot device number. Device family and temperature range prefix see table 3A. Table 2 underscore package description. Suffix package description. PNB dash, 14 dash, 16 dash, 18 dash, 20 dash, 24 dash, 2B dash, 40 lead plastic dip. To micro miniature package, so. Of 14 dash, 16 dash, LB dash, 22 dash, 24 lead ceramic dip. Use single inline plastic, SIP, and SIP power packages. Table 3 underscore device prefix. Prefix device family. Hex CMOS circuit. OM linear circuit. PCX CMOS circuit. PNX NMOS circuit. SAX digital circuit. TDX linear circuit. TEX linear circuit. 1 to 35. Synutics section 2. Quality and reliability. Linear products. Index. 2 to 3. Zero defects program, colon 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 dot colon 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 colon. 2 to 7 Synutics LAR process flow. Linear division me. I. Synutics. Linear products. Signetics zero defects. Program. In recent years, American industry has demanded increased product quality of its IC suppliers in order to meet growing international competitive pressures. As a result of this quality focus, it is becoming clear that what was once thought to be unattainable, zero defects, is, in fact, achievable. The IC supplier committed to a standard of zero defects provides a competitive advantage to today's electronics OEM. That advantage can be summed up in 4 words. Reduced cost of ownership. As IC customers look beyond purchase price to the total cost of doing business with a vendor, it is apparent that the quality-conscious supplier represents a viable cost reduction resource. Consistently, high-quality circuits reduce requirements for expensive test equipment and personnel, and allow for smaller inventories, less rework, and fewer field failures, reducing the cost of ownership through total quality performance. Quality involves more than just ICs that work. It also includes cost-saving advantages that come with error-free service, on-time delivery of the right quantity of the right product at the agreed-upon price. Beyond the product, you want to know you can place an order and feel confident that no administrative problems will arise to tie up your time and personnel. Today, as a result of Signetics' growing appreciation of the concern with cost of ownership, our quality improvement efforts extend out from the traditional areas of product conformance into every administrative function, including order entry, scheduling, delivery, shipping, and invoicing. Driving this process is a corporate quality improvement Team, comprised of the president and his staff, which oversees the activities of 30 other quality improvement teams throughout the company. Linear product quality. Synthetix has put together a winning process for the manufacturing of linear integrated circuits. The circuits produced by our linear division must meet rigid criteria as defined in our design rules and as evaluated through product characterization over the device operating temperature range. December 1988. Quality and reliability. Product conformance to specification is assured throughout the manufacturing cycle. Synthetix calls the first submittal to a product or quality assurance gate are estimated process quality or EPQ. It is an internal measure used to drive our quality improvement programs toward our goal of zero defects. All product acceptance sampling plans have zero as their acceptance criteria. Only shipments that demonstrate zero defects during these acceptance tests may be shipped to our customers. This is in accordance with our commitment to our zero defect policy. Our standard is zero defects and our custom ERS statistics and awards for outstanding product quality demonstrate our advance toward this goal. Nowhere is this more evident than at our electrical and visual mechanical outgoing product assurance inspection gates. Over the past 8 years, the MEA assured defect level at the first submission to electrical product assurance for linear products has dropped from over 4,000 ppm, 0.4%, to under 50 ppm, 0.005%. See figure law. Similarly, our visual mechanical, body defects, lead bend, etc., defect level has improved remarkably, see figure 1b. The results from our quality improvement program have allowed Synthetix to take the industry leadership position with its zero defects limit warranty policy. No longer is it necessary to negotiate a mutually acceptable AQLB between buyer and Synthetix. Synthetix will replace any lot in which a customer finds one verified defective part. Quality database reporting system, QA05. The capabilities of our manufacturing process are measured and the results are recorded through our corporate-wide QA05 database system. The QA05 system collects the results on all finished lots and feeds this data back to concerned organizations where appropriate corrective actions can be taken. The QA05 reports estimated process quality, EPQ, data, which are the sample inspection results for first submittal lots to quality assurance inspection for electrical, visual/mechanical, harmonicity, and documentation. Data from this system is available upon request and is distributed routinely to our customers who have formally adopted our ship-to-stock program. 2-3. Customer/vendor cooperation is at the heart of zero defects and reduced costs. Working to a zero defects standard requires that emphasis be consistently placed, not on catching defects, but on preventing them from ever occurring. This strong preventive focus, which demands that quality be built in rather than inspected in, includes a much greater attention to ongoing communication on quality-related issues. At Synthetix, a focus on this cooperative approach has resulted in better service to all customers and the development of two innovative customer/vendor programs, SHLP to stock and self-qual. Signetics SHLP to stock program. SHLP to stock is a joint program between Signetics and a customer which formally certifies specific parts to go directly into inventory or to the assembly line from the customer's receiving dock without incoming inspection. This program was developed at the request of several major customers after they had worked with us and had a chance to experience the data exchange and joint corrective action that occurs as part of our quality improvement program. The key elements of the ship-to-stock program are: Signetics and customer agree on a list of products to be certified, complete device correlation, and sign a specification. The product estimated product quality EPQ must be 300 ppm or less for the past 3 months. Signetics will share quality, QA05, and reliability data on a regular basis. Signetics will alert ship-to-stock customers of any changes in quality or reliability which could adversely impact their product. Any customer interested in the benefits of the ship-to-stock program should contact his local Signetics sales office for a brochure and further details. As a result of their participation in the ship-to-stock program, many of our customers have eliminated costly incoming testing on select ICS. We will work together with any customer interested to establish a ship-to-stock program, and identify the products to be included in the program and finalize all necessary Signetics linear products. ppm, parts per million. 500. 400. 1985, 1986, 1987. Year: 1988, 1989. Figure law. Product electrical quality. ppm, parts per million. 600. 500. 400. 300. 1985, 1986, 1987. Year: 1988, 1989. Figure 1b. Visual mechanical quality. Sorry, terms and conditions. From that point, the specified products can go directly from the receiving dock to the assembly line or into inventory. Signetics then provides, free of charge, monthly reports on those products. December 1988. In our efforts to continually reduce cost of ownership, we are now using the experience we have gained with ship-to-stock to begin developing a just-in-time program. With just-in-time, products will be delivered to the receiving dock list as they are needed, per melt. 2 to 4. Quality and reliability. Ting continuous flow manufacturing and eliminating the need for expensive inventories. Signetics self-qual program. Like ship-to-stock, our self-qual program employs a cooperative approach based on ongoing information exchange. At Signetics, formal qualification procedures are required for all new or changed materials, processes, products, and facilities. Prior to 1983, we created our qualification programs independently. Our major customers would then test samples to confirm our findings. Now, under the new self-qual program, customers can be directly involved in the pre-qualification stage. When we feel we have a promising enhancement to offer, customers will be invited to participate in the development of the qualification plan. This eliminates the need to duplicate expensive qualification testing and also adds another dimension to our ongoing efforts to build in quality. We want to work with you. At Syniotix, we know that our success depends on our ability to support all our custom ERS with the defect-free, higher density, higher performance products needed to compete effectively in today's demanding business environment. To achieve this goal, quality in another arena, that of communications, is vital. Here are some specific ways we can maintain an ongoing dialogue and information exchange between your company and ours on the quality issue. Periodical face-to-face exchanges of data and quality improvement ideas between the customer and Syniotix can help prevent problems before they occur. Test correlation data is very useful. Line pull information and field failure reports also help us improve product performance. When a problem occurs, provide us as soon as possible with whatever specific data you have. This will assist us in taking prompt corrective action. Quality products are, in large measure, the result of quality communication. By working together, by opening up channels through which we can talk openly to each other, we will ensure the creation of the innovative, reliable, cost-effective products that help ensure a competitive edge. Quality and reliability. Assurance. Syniotix Linear Division Quality and Reliability Assurance Department is involved in all stages of the production of our linear IGs. Syniotix Linear Products. Product design and process development, wafer fabrication, assembly, inspection and test, product reliability monitoring, customer liaison. The result of this continual involvement at all stages of production enables us to provide feedback to REFMA present and future designs, manufacturing processes, and test methodology to enhance both the quality and reliability of the products delivered to our customers. Reliability begins with the design. Quality and reliability must begin with design. No amount of extra testing or inspection will produce reliable ICS from a design that is inherently unreliable. Syniotix follows very strict design and layout practices with its circuits to eliminate the possibility of metal migration. Current density in any path cannot exceed 5x10 5 amps low CM2. Layout rules are followed to minimize the possibility of shorts, circuit anomalies, and SCR-type latch-up effects. All circuit designs are computer checked using the latest CAD software for adherence to design rules. Simulations are performed for functionality and parametric performance over the full operating ranges of voltage and temperature before going to production. These steps allow us to meet device specifications not only the first time, but also every time thereafter. Product characterization. Before a new design is released, the characterization phase is completed to ensure that the distribution of parameters resulting from AutoIt variations is well within specified limits. Such extensive characterization data also provides a basis for identifying unique Applicant-related problems which are not part of normal datasheet guarantees. Reliability measurement. Programs. Synthetix has developed comprehensive product and process qualification programs to assure that its customers are receiving highly reliable products for their critical applications. Additionally, ongoing reliability monitoring programs, Sure 3 and Product Monitor. Sample standard production product on a regularly established basis, see Table IB. Low. Description of stresses. SHTL, static high temperature life. SHTL stress applies static DC bias to the device. This has specific merit in detecting ionic contamination problems which require continuous uninterrupted bias to drive contaminants to the silicon surface. DHTL stress ing is not as effective in detecting such problems because the bias continuously. Table I reliability assurance programs. Reliability function typical stress. New process qualification high temperature operating life. Bias temperature humidity, static. High temperature storage life. Pressure pot. Temperature cycle. New product qualification high temperature operating life. Bias temperature humidity, static. High temperature storage life. Pressure pot. Temperature cycle. Electrostatic discharge characterization. Sure 3 high temperature operating life. Bias temperature humidity, static. High temperature storage life. Pressure pot. Temperature cycle. Thermal shock. Product monitor pressure pot. Thermal shock. December 1988 2-5. Quality and reliability. Changes, intermittently generating and healing the problem. HTSL, high temperature storage life. This stress exposes the parts to elevated temperatures, 150 C, 175 C, with no AP. Applied bias. THBS, bias temperature humidity. Static, this accelerated temperature and humidity bias stress is performed at 85 C and 85% relative humidity, 85 C/85% RH. TMCL, temperature cycling, air to air. The device is cycled between the specified upper and lower temperature without power in an air or nitrogen environment. Normal temperature extremes are -65 C and +150 C with a minimum 10 mute dwell and 5-minute transition per mil STD 883 C, meth. OD 1010.5, Condilon C. This is a good test to measure the overall package to die mechanical compatibility, because the thermal expansion coefficients of the plastic are normally very much higher than those of the die and lead frame. PPOT, pressure pot. This stress exposes the devices to saturated steam at elevated temperature and pressure. The standard condition is 20 psig, which occurs at a temperature of 127 C and 100% RH. The stress is used to test the moisture resistance of plastic encapsulated devices. Because the steam environment has an unlimited supply of moisture and ample temperature to catalyze the Mali activated events, it is effective at detecting corrosion problems, contamination in frequency. Each new wafer fab process. Each new product. Each fab process family. Every 4 weeks. Each package type and technology family at each assembly plant, every week. Synthetix linear products. Duchade leakage problems, and general glass low. Vashon stability and integrity. TMSK, thermal shock, liquid IO liquid. Similar to TMCL, however, heating and cooling are done by immersing the units in hot and cold inert liquid. Temperature extremes are -65 degrees Celsius to +150 degrees Celsius with a minimum 5-minute dwell and less than 10-second transition per me STD 883C, method 1011.4, condition C. Since heat transfer by conduction is generally much faster than by convection, the liquid-based thermal shock causes more rapid temperature changes in the part. Product qualification. Linear products are subjected to rigorous qualification procedures for all new products or redesigns to current products. Qualification testing consists of high temperature operating life. TJ equals 150 degrees Celsius, 1000 hours, static bias. High temperature storage life. TJ equals 175 degrees Celsius, 1000 hours, unbiased. Temperature humidity biased life. 85 degrees Celsius, 85% relative humidity, 1000 hours, static bias. Pressure cooker. 20 pslg, 127C, 168 hours, unbiased. Temperature cycle. -65 degrees Celsius to +150 degrees C, 500 cycles, 10-minute dwell, air-to-air, unbiased. Formal qualification procedures are required for all new or changed products, processes, and facilities. These procedures ensure the high level of product reliability our customers expect. New facilities are qualified by corporate groups as well as by the quality organelles of specific units that will operate in the facility. After qualification, products manufactured by the new facility are subjected to highly accelerated environmental stresses to ensure that they can meet rigorous failure rate requirements. New or changed process ES are similarly qualified. December 1988. Ongoing reliability assessment programs. The SURE program. The SURE, Systematic and Uniform Reliability TIE Evaluation, program audits products from each of Signatul's linear DVS-ONS process families, bipolar junction, SLNGJE layer metal, dual layer metal, GDLD doped, and Schottky oxide isolated and ACMOS, under a variety of accelerated stress conditions. This program, first introduced in 1964, has evolved to suit changing product complexities and performance requirements. The audit program. Samples are selected from each process family every 4 weeks and are subjected to each of the following stresses. High temperature operating life. TJ equals 150 degrees Celsius, 1000 hours, static bias. Temperature humidity biased life. 85 degrees Celsius, 85% relative humidity, 1000 hours, static bias. Pressure cooker. 20 pslg, 127C, 72 hours, unbiased. Thermal shock. -65 degrees Celsius to +150 degrees Celsius, 300 cycles, 5-minute. Dwell, liquid to liquid, unbiased. Temperature cycling. -65 degrees Celsius to +150 degrees Celsius, 1000 cycles, 10-minute dwell, air-to-air, unbiased. The Product Monitor Program. In addition, each Synytex assembly plant performs pressure cooker and thermal shock sure product monitoring stresses on a weekly basis on each molded package by pin count per the same conditions as the sure program. Product reliability reports. The data from these test matrices provides a basic understanding of product capability, an indicalion of major failure mechanisms, and an estimated failure rate resulting from each stress. This data is compiled periodically and is available to customers upon request. 2-6. Quality and reliability. Many customers use this information in lieu of running their own qualification tests, thereby eliminating time-consuming and costly additional testing. Reliability engineering. In addition to the product performance monitors encompassed in the Linear Sure program, Synytex corporate and division reliability engineering departments sustain a broad range of evaluation and qualification activities. Included in the engineering process are evaluation and qualification of new or changed materials, assembly/wafer fab processes and equipment, product designs, facilities, and subcontractors. Device or generic group failure rate studies. Advanced environmental stress development. Failure mechanism characterization and corrective client/prevention reporting. The environmental stresses utilized in the engineering programs are similar to those utilized for the Sure monitor, however, more highly accelerated conditions and extended durations typify these engineering projects. Additional stress systems such as biased pressure pot, power temperature cycling, and cycle biased temperature humidity are also included in some evaluation programs. Failure analysis. The Sure program and the Reliability Engineering program both include failure analysis activities and are complemented by corporate, divisional, and plant failure analysis departments. These engineering units provide a service to our customers who desire detailed failure analysis support, who in turn provide Synytex with the technical understanding of the failure modes and mechanisms actually experienced in service. This and formally an is essential in our ongoing effort to accelerate and improve our understanding of product failure mechanisms and their prevention. Synytex linear products. Quality and reliability. Linear division linear process flow. December 1988. 0--- scanning electron microscope control. Wafers of sampled daily by the Quality Control Laboratory from each Fab-Catlon area and subjected to SEM analysis. This process control reveals manufacturing defects such as contact and oxide step coverage in the Metazone process, which may result 111 early failures. 0--- die sort visual acceptance. Product is inspected for defects caused dung Fab-Catlon, wafer testing, or the mechanical SKB. And break Opalon detects such as scratches, smears, and glass-elevated bonding pads are included in the lot acceptance criteria. Die and ACH and wire bonding. The latest automated equipment is used under statistical process control program. O___________________ pre-seal visual acceptance. Product is inspected to detect any damage incurred at the die attach and wife bonding stations. Defects such as scratches, contamination and smeared ball B of JS are included in the 101 acceptance. Ndina. Underscore 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 seal tests. Hermetic package seal integrity is ensured by 100% and fine gross leak testing. Symbol. Devices are marked with HESLONETL CS logo, device number, and PNO date code of assembly or custom symbol per individual Speklacatlon requirements. Underscore 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 100% production electrical testing. Every device is tested to all datasheet parameters guaranteeing temperature Speklacatlons. Burn in, SUPR2 level B option. Devices are burned in for 21 hours at 155 C maximum junction temperature. 100% production electrical testing. Every device is tested to all datasheet parameters guaranteeing temperature specifications. Underscore 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 visual. O products are visually inspected per the requirements specified in Signetix or customer documents. Underscore 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 final quality assurance gate. The final QA inspection step guarantees the SPE cleed mechanical and electrical AOLs every ship. Meant is sealed and identified by QA personnel. 2-7. Signetix linear products. Signetix manufacturing facilities. Signetix, as part of a multinational corporation, utilizes manufacturing facilities for wafer fabrication, package assembly, and test in 3 states and 3 overseas countries as shown in Table 2. All wafer fabrication is performed in Signetix operated fabs which report to the Vice President of Die Manufacturing Operations, DMO, in Sunnyvale, Simi. Larly, Signetix assembly operations in Utah, Korea, and Thailand, report to the Vice President of Assembly Manufacturing Operations. AMO. Assembly subcontractors, Pebble and ANAM, are scheduled and controlled through the AMO organization. Assembly subcontract. Tours process all product to Signetix specify cations and materials. Signetix has on-site. Table 2. Signetix linear product manufacturing facilities. Wafer fabrication facilities. Designation location process families. Fab 01 Sunnyvale, California bipolar junction isolated. Fab 09 Orem, Utah bipolar gold doped. Fab 16 Sunnyvale, California oxide isolated. Fab 21 Orem, Utah bipolar Schottky. Fab 22 Albuquerque, New Mexico ACMOS. Assembly facilities. Designation location package. SLG Core Seoul, Korea DIP, SO, and PLCC. SLG Thai Bangkok, Thailand DIP and SIRDIP. Orem Utah Military Jan Hermetic. Pebble Ko Slung, Taiwan SO. Annam Seoul, Korea SO and Metal Can. Test facilities. Designation location package. TA 03 Sunnyvale, California wafer sort, final test. And quality assurance. SLG Core Seoul, Korea final test and quality assurance. SLG Thal Bangkok, Thailand final test and quality assurance. SACTO Sacramento, California military final test and quality assurance. December 1988 2-8. Quality and reliability. Quality assurance personnel at each subcon tractor to audit assembly processes and procedures. All Signetix linear products are electrically tested in Signetix operated facilities. These facilities report to the manufacturing organization, DMO or AMO, operating the facility at which they are located. Synotics linear products. Symbolization information. Synotics linear DVS on products are symboled with the following information on each package. Synotics logo. Product identification and package designator. Traceability code. Assembly date and plant codes. Product revision level. SUPR2B processing code, if applicable. May appear on the backside of SO8, 14 and 16 lead. Packages due to space limitations on topside symbol. Example. SNE5534N line 1. FBW5491 line 2. 8901 VCB line 3. Line 1. S equals Synotics logo. NE5534 equals product type designation. N equals package type. N equals dual inline plastic. F equals dual inline SER DLP. D equals small outline, so, surface mount. A equals plastic leaded chip carrier, PLCC. E or H equals metal header. Line 2. FBW5491 equals 7-character traceability code assigned to each assembly lot which maintains product traceability back to the wafer fabric colon. May be truncated on SO8 and metal headers. Line 3. 8901 equals assembly date code, YYWW, specifies the year, YY. YYWW, and week number, WW, that begins the 4-week assembly period during which the product was manufactured. Thus, 8901 indicates that the product was packaged during the first 4 weeks of 1989. The first digit of the year may be omitted on some packages, 901. V equals assembly plant code which indicates the assembly facility in which the finished product was packaged. Assembly plants codes are V equals Synotics Bangkok, Thailand. K equals Synotics Seoul, Korea. B equals Philips Kaohsiung, Taiwan. L equals Annam Seoul, Korea. C equals product revision level. B equals SUPR2B burn-in processing code, if present. Indicates that the product was processed through 100% SUPR2B burn-in for 21 hours. Under biased opéralon at a Junkalon temperature, TJ, of 155 degrees Celsius. December 1988 2-9. Quality and reliability. Section 3. Small area networks. Synotics. Linear products. Index. Introduction to 1C2. 3-3. 1C2 bus specification. 3-4. And 168 the inter-integrated circuit, 12C, serial bus. Theory and practical considerations. 3-16. Synotics. Linear products. The 1-2C concept. The inter-IC bus, 12C, is a 2-wire serial bus designed to provide the facilities of a small area network, not only between the circuits of one system, but also between different SYS TEMs, example teletext and tuning. Philips/Synotics manufactures many devices with built-in 1C2 interface capability, any of which can be connected in a system by simply clipping it to the 1C2 bus. Hence, any collection of these devices around the 1C2 bus is known as clips. The 1-2C bus consists of 2 bidirectional lines, the serial data, SDA, line and the serial clock, SCL, line. The output stages of devices connected to the bus. These devices could be NMOS, CMOS, 12C, TTL, must have an open drain or open collector in order to perform the wired and function. Data on December 1988. Introduction to 1C2. The 1C2 bus can be transferred at a rate up to 100 bit/section. The physical bus length is limited to 13 feet and the number of devices connected to the bus is solely dependent on the limiting bus capacitance of 400 pf. The inherent synchronization process, built into the 1C2 bus structure using the wired and technique, not only allows fast devices to communicate with slower ones, but also eliminates the carrier sense multiple AC SES/collision detect, CSMA/CD, effect. Found in some local area networks, such as Ethernet. Master-slave relationships exist on the 1C2 bus, however, there is no central master. Therefore, a device addressed as a slave during one data transfer could possibly be the master for the next data transfer. Devices are 3-to-3. Also free to transmit or receive data during a transfer. To summarize, the 1C2 bus eliminates interfacing problems. Since any peripheral device can be added or taken away without affecting any other devices connected to the bus, the 1C2 bus enables the system designer to build various configurations using the same basic architecture. Application areas for the 1C2 bus include video equipment, audio equipment, computer terminals, home appliances, telephony, automotive, instrumentation, industrial control, Signetics, linear products. Introduction. For 8-bit applications, such as those requiring single-chip microcomputers, certain design criteria can be established. A complete system usually consists of at least one microcomputer and other peripheral devices, such as memories and 1/0 expanders. The cost of connecting the various devices within the system must be kept to a minimum. Such a system usually performs a control function and does not require HLGH speed data transfer. Overall efficiency depends on the devices chosen and the interconnecting bus structure. In order to produce a system to satisfy these criteria, a serial bus structure is needed. Although serial buses don't have the throughput capability of parallel buses, they do require less wiring and fewer connecting pins. However, a bus is not merely an interconnecting wire, it embodies all the formats and procedures for communication within the SYS. Devices communicating with each other on a serial bus must have some form of protocol which avoids all possibilities of confusion, data loss and blockage of information. Fast devices must be able to communicate with slow devices. The system must not be dependent on the devices connected to it, otherwise modifications or improvements would be impossible. A procedure has also to be solved to decide which device will be in control of the bus and when. And if different devices with different clock speeds are connected to the bus clock source must be defined. All these criteria are involved in the specification of the 12C bus. The 12C bus concept Any manufacturing process, NMOS, CMOS. 12L, can be supported by the 12C bus. 2. Wires, SDA, serial data, SCL serial clock. Carry information between the devices connect to the bus. Each device is recognized by a unique address, whether it is a micro computer, LCD driver, memory, or keyboard interface, and can operate as either a transmitter or receiver, depending on the function of the device. Obviously, an LCD driver is only December 1988. 1C2 bus. Specification. A receiver, while a memory can both receive and transmit data. In addition to transmitters and receivers, devices can also be considered as masters or slaves when performing data transfers, see Table 1. A master is the device which initiates a data transfer on the bus and generates the clock signals to permit that transfer. At that time, any device addressed is considered a slave. The 12C bus is a multi-master bus. This means that more than one device capable of controlling the bus can be connected to it. As masters are usually microcomputers, let's consider the case of a data transfer between two microcomputers connected to the 12C bus, Figure 1. This highlights the master, slave and receiver transmitter relationships to be found on the 12C bus. It should be noted that these relationships are not permanent, but only depend on the direction of data transfer at that time. The transfer of data would follow in this way. 1. Suppose microcomputer A wants to send information to microcomputer B. Microcomputer A, master, addresses. Microcomputer B, slave. Microcomputer A, master transmitter, sends data to microcomputer B, slave. Receiver. Microcomputer A terminates the transfer. 2. If microcomputer A wants to receive information from microcomputer B. Microcomputer A, master, addresses. Microcomputer B, slave. Microcomputer A, master receiver, receives data from microcomputer B. Slave transmitter. Microcomputer A terminates the transfer. Even in this case, the master, microcomputer A, generates the timing and terminates the transfer. The possibility of more than one microcomputer being connected to the 1C2 bus means that more than one master could try to initiate a data transfer at the same time. To avoid the chaos that might ensue from such an event, an arbitration procedure has been developed. This procedure relies on the wired and connection of all devices to the 12C bus. If two or more masters try to put information onto the bus, the first to produce a 1 when the other produces a 0 will lose the arbitration. The clock signals during arbitration are a synchronized combination of the clocks generated by the masters using the wired and connection to the SCL line. 4. More detailed information concerning arbitration, see arbitration and clock generation. Generation of clock signals on the 12C bus is always the responsibility of master devices. Each master generates its own clock signals when transferring data on the bus. Bus clock signals from a master can only be altered when they are stretched by a slow slave. Figure 1. Typical 12C bus configuration. 3-4. Synthetix linear products. 1C2 bus specification. Table 1. Definition of 12C bus terminology. Term description. Transmitter, the device which sends data to the bus. Receiver, the device which receives data from the bus. Master, the device which initiates a transfer, generates clock signals and terminates a transfer. Slave, the device addressed by a master. Multiple master, more than one master can attempt to control the bus at the same time without corrupting the message. Arbitration procedure, to ensure that if more than one master simultaneously tries to control the bus, only one is allowed to do so and the message is not corrupted. Synchronization procedure, to synchronize the clock signals of two or more devices. R plus VDD. SDA, serial data line. SCL underscore underscore L underscore C underscore underscore K Li underscore N underscore E underscore 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 plus dash underscore 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 plus dash underscore underscore RIJ III ISCLK1JI IOI ISCLK2JI IOI III III SCLK data I in I ISCLK data II in I L underscore 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 JL underscore 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 J. Device 1, Device 2. Figure 2. Connection of devices to the 12C bus. II. SDA. J, E plus colon. III. SCL. ICI colon dot, I data valid I allowed I. Figure 3. Bit transfer on the 12C bus. Figure 4. Start and stop conditions. December 1988 3-5. Device holding down the clock line or by another master when arbitration takes place. General characteristics. Both SDA and SCL are bidirectional lines, connected to a positive supply voltage via a pull-up resistor, see Figure 2. When the bus is free, both lines are high. The output stages of devices connected to the bus must have an open drain or open collector in order to perform the wired and function. Data on the 1C2 bus can be transferred at a rate up to 100 kblt/s. The number of devices connected to the bus is solely dependent on the limiting bus capacitance of 400 pf. Bit transfer. Due to the variety of different technology devices, CMOS, NMOS, 12L, which can be connected to the 1C2 bus, the levels of the logical 0, low, and 1, high, are not fixed and depend on the appropriate level of VDD, see electrical specifications. 1 clock pulses generated for each data bit transferred. Data validity. The data on the SDA line must be stable during the high period of the clock. The high or low state of the data line can only change when the clock signal on the SCL line is low. Figure 3. Start and stop conditions. Within the procedure of the 1C2 bus, unique situations arise which are defined as start and stop conditions, see Figure 4. A high to low transition of the SDA line while SCL is high is one such unique case. This situation indicates a start condition. A low to high transition of the SDA line while SCL is high defines a stop condition. Start and stop conditions are always generated by the master. The bus is considered to be busy after the start condition. The bus is considered to be free again a certain time after the stop condition. This bus-free situation will be described later in detail. Detection of start and stop conditions by devices connected to the bus is easy if they possess the necessary interfacing hardware. However, microcomputers with no such interface have to sample the SDA line at least twice per clock period in order to sense the transition. Transferring data. Byte format. Every by1E put on the SDA line must be 8 bits long. The number of bytes that can be transmitted per transfer is unrestricted. Each by1E must be followed by an acknowledge bit. Syntactics linear products. 12C bus specification. Byte complete. Interrupt within receiver. Sidcon held IJN/while. Interrupts are serviced. Figure 5. Data transfer on the 12C bus. EX. Data output II/. XBYTRANSMRRTERII underscore dot L underscore 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 J underscore 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 OJ. II. Data output II. By receiver II. SC colon, C, II. ISI. L colon J. Start. CONDMON. Data is transferred with the most significant bit, MSB, first, figure 5. If a receiving device cannot receive another complete byte of data until it has performed some other function, for example, to service an internal interrupt, it can hold the clock line SCL low to force the transmitter into a wait state. Data transfer then continues when the receiver is ready for another byte of data and releases the clock line SCL. In some cases, it is permitted to use a different format from the 1C2 bus format, such as CBUS compatible devices. A message which starts with such an address can be terminated by the generation of a stop condition, even during the transmission of a byte. In this case, no acknowledge is generated. Acknowledge. Data transfer with acknowledge is obligatory. The acknowledge-related clock pulse is generated by the master. The transmitting device releases the SDA line, high, during the AC knowledge clock pulse. December 1988. Figure 6. Acknowledge on the 12C bus. The receiving device has to pull down the SDA line during the acknowledge clock pulse, so that the SDA line is stable low during the high period of this clock pulse, figure 6. Of course, setup and hold times must also be taken into account, and these will be described in the timing section. Usually, a receiver which has been addressed is obliged to generate an acknowledge after each byte has been received, except when the message starts with a CBUS address. When a slave receiver does not acknowledge on the slave address, for example, because it is unable to receive while it is performing some real-time function, the data line must be left high by the slave. The master can then generate a stop condition to abort the transfer. If a slave receiver does acknowledge the slave address, but sometime later in the transfer cannot receive any more data bytes, the master must again abort the transfer. This is indicated by the slave not generating the acknowledge on the first byte following the 3 to 6 SID pulls for acknowledgement. Slave leaves the data line high and the master generates the stop condition. In the case of a master receiver involved in a transfer, it must signal an end of data to the slave transmitter by not generating an AC knowledge on the last byte that was clocked out of the slave. The slave transmitter must release the data line to allow the master to generate the stop condition. Arbitration and clock generation. Synchronization. All masters generate their own clock on the SCLIN to transfer messages on the 1C2 bus. Data is only valid during the clock high period. On the SCL line, therefore, a defined clock is needed if the bit-by-bit arbitration procedure is to take place. Clock synchronization is performed using the wired AND connection of devices to the SCL line. This means that a high to low transient takes linear products. 1C2 bus specification. CLK 1. Start counting. I wait dash plus period. I state I dash backslash dash dot dash 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 dash. CLK 2 underscore 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 dash dash 7 dash dash underscore underscore J dash 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 dash. SCL. Figure 7. Clock synchronization during the arbitration procedure. Data 1. Transmitter 1 LTS's arbitration. Data 1 plus SDA. Data 2 LJ1 dash 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 R dash dash. SDA. Figure 8. Arbitration procedure of two masters. Lion on the SCL line will affect the devices concerned, causing them to start counting off their low PNO. Once a device clock has gone low, it will hold the SCL line in that state until the clock high state is reached, figure 7. However, the low to HLGH change in this device clock may not change the state of the SCL line if another device clock is still within its low PNO. Therefore, SCL will be held low by the device with the longest low period. Devices with shorter low periods enter a high walled state during this time. When all devices concerned have counted off their low PNO, the clock line will be released and go high. There will then be no difference between the device clocks and the December 1988 state of the SCL line, and all of them will start counting their high PNOs. The first device to complete its high PNO will again pull the SCL line low. In this way, a synchronized SCL clock is generated for which the low PNO is determined by the device with the longest clock low period, while the high period on SCL is determined by the device with the shortest clock high PNO. Arbitration. Arbitration takes place on the SDA line in such a way that the master which transmits a high level, while another master transmits a low level, will switch off its data output stage, since the level on the bus does not correspond to its own level. 3 to 7. Arbitration can carry on through many bits. The first stage of arbitration is the comparison of the address bits. If the masters are each trying to address the same device, arbitration continues into a comparison of the data. Because address and data information is used on the 1C2 bus for the arbitration, no information is lost during this process. A master which loses the arbitration can generate clock pulses until the end of the byte in which it loses the arbitration. If a master does lose arbitration during the addressing stage, it is possible that the winning master is trying to address it. Therefore, the losing master must switch over immediately to its slave receiver mode. Figure 8 shows the arbitration procedure for two masters. Of course, more may be involved, depending on how many masters are connected to the bus. The moment there is a difference between the internal data level of the master generating data 1 and the actual level on the SDA line, its data output is switched off, which means that a high output level is then connected to the bus. This will not affect the data transfer initiated by the winning master, as control of the 1C2 bus is decided solely on the address and data sent by competing masters. There is no central master, nor any order of priority on the bus. Use of the clock synchronizing mechanism as a handshake. In addition to being used during the arbitral on procedure, the clock synchronization mechanism can be used to enable receiving devices to cope with fast data transfers, either on a byte or bit level. On the byte level, a device may be able to receive bytes of data at a fast rate, but needs more time to store a received byte or prepare another byte to be transmitted. Slave devices can then hold the SCL line low, after reception and acknowledge of a byte, to force the master into a wait state until the slave is ready for the next byte transfer in a type of handshake procedure. On the bit level, a device such as a micro computer without a hardware 1C2 interface on chip can slow down the bus clock by extending each clock low period. In this way, the speed of any master is adapted to the internal operating rate of this device. Synthetix linear products. J2C bus specification. Formats. Data transfers follow the format shown in Figure 9. After the start condition, a slave address is sent. This address is 7 bits long. The 8th bit is a data direction bit, r/in. A 0 indicates a transmission, write, a 1 indicates a request for data, read. A data transfer is always terminated by a stop condition generated by the master. However, if a possible data transfer formats are a master transmitter transmits to slave receiver, direction is not changed. A acknowledge, S start, P equals stop. B master reads slave immediately after first byte. C combined formats. Notes: master still wishes to communicate on the bus, it can generate another start condition and address another slave without first generating a stop condition. Various combinations of read/write formats are then possible within such a transfer. At the moment of the first acknowledge, the master transmitter becomes a master receive. Figure 9. A complete data transfer. S8 slave address r/WA. O, WIIILE. S slave address r/WA. ER and the slave receiver becomes a slave transmitter. This acknowledge is still generated by the slave. The stop condition is generated by the master. During a change of direction within a transfer, the start condition and the slave address are both repeated, but with the R/W bit reversed. Data AAP 11. IIO1 UA transferred. N bytes plus acknowledge. AIIO1 UAAP 11. IIO1 UA transferred. N bytes plus acknowledge. Is I slave address IJRLWIA T.J. S I slave Adoris IRJWI all, RI. N bytes plus ACKNOWLEDGFJ plus acknowledge. Read or direction of WRRRE transfer may. Changer. This point. AF, L351 OS. One combined formats can be used, for example. To control a serial memory dung the first data byte, the internal memory locaben has to be unten after the start candleban is repeated. Data can then be transferred. All decisions on auto-increment or decrement of previously accessed memory locations, etc. are taken by the designer of the device. Each byte is followed by an acknowledge as indicated by the A blocks in the sequence. 12 devices have to reset their bus logic on receipt of a start condition so that they all anticipate the sending of a slave address. December 1988 38. Synutix Linear Products 1C2 bus specification. Addressing. The first byte after the start condition determines which slave will be selected by the master. Usually, this first byte follows that start procedure. The exception is the general call address, which can address all devices. When this address is used, all devices should, in theory, respond with an acknowledge, although devices can be made to ignore this address. The second byte of the general call address then defines the action to be taken. Definition of bits in the first byte. The first 7 bits of this byte make up the slave address, figure 10. The 8th bit, LSB, least significant bit, determines the direction of the message. A 0 on the least significant position of the first byte means that the master will write information to a selected slave. A 1 in this position means that the master will read information from the slave. MSA. Slave address. Figure 10. The first byte after the start procedure. When an address is sent, each device in a system compares the first 7 bits after the start condition with its own address. If there is a match, the device will consider itself addressed by the master as a slave receiver or slave transmitter, depending on the R/W bit. The slave address can be made up of a fixed and a programmable part. Since it is expected that identical ICS will be used more than once in a system, the programmable part of the slave address enables the maximum possible number of such devices to be connected to the 12C bus. The number of programmable address bits of a device depends on the number of pins available. For example, if a device has 4 fixed and 3 programmable address bits, a total of 8 identical devices can be connected to the same bus. The 12C bus committee is available to coordinate allocation of 12C addresses. The bit combinalon 1111 XXX of the slave address is reserved for future extension purposes. The address 111.1111 is reserved as the extension address. This means that the addressing procedure will be continued in the next byte, s. Devices that do not use the extended addressing do not react at the Reception of this byte. The 7 other posse. December 1988. LSB. IA Actherx XXBA. F1RSRBYTE. General call address. Second byte. Figure 11. General cal. Address format. H06. ISIHOOIAIH22IAIABDOC1IXIAIABCD010IXIAIPI. Figure 12. Sequence of a programming master. Blitties in group 1111 will also only be used for extension purposes but are not yet allocated. The combinalanoths has been defined as a special group. The following addresses have been allocated. First byte. Slave. Address r/w. 0000000 a general call address. 000000001 start byte. 0000001 XCBUS address. 0000010X address reserved for different bus format. 0000 all X. 0000100X. 0000101X. 0000110X. 0000111X. No device is allowed to acknowledge at the reception of the start byte. The CBUS address has been reserved to enable the intermixing of CBLLS and 12C devices in one system. 12C bus devices are not allowed to respond at the reception of this address. The address reserved for a different bus format is included to enable the mixing of 12C and other protocols. Only 12C devices that are able to work with such formats and protocols are allowed to respond to this address. General cal address. The general call address should be used to address every device connected to the 12C bus. However, if a device does not need any of the data supplied within the general call structure, it can ignore this address by not acknowledging. If a device does require data from a general call address, it will acknowledge 3 to 9. Edge this address and behave as a slave receiver. The second and following bytes will be acknowledged by every slave receiver capable of handling this data. A slave which cannot process one of these bytes must ignore it by not acknowledging. The meaning of the general call address is always specified in the second byte, figure 11. There are two cases to consider. 1 when the least significant bit BIS a 0. 2 when the least significant bit BIS a 1. When B is a 0, the second byte has the following definition. 000000110, H06, reset and write the programmable part of slave address by software and hardware. On receiving this 2-byte sequence, all devices designed to respond to the general call address will reset and take in the programmable part of their address. Precautions must be taken to ensure that a device is not pulling down the SDA or SCL line after applying the supply voltage, since these low levels would block the bus. 000000010, H02, write slave address by software only. All devices which obtain the programmable part of their address by software, and which have been designed to Spawn to the general call. Address will enter a mode in which they can be programmed. The device will not reset. Synutix linear products. J2C bus specification. An example of a data transfer of a program. Ming master is shown in figure 12, ABCD. Represents the fixed part of the address. 000000100, H04, write slave address by hardware only. All devices which define the program mabel part of their address by hardware, and which respond to the general call address, will latch this programmable part at the reception of this 2-byte sequence. The device will not reset. 000000000, HOO, this code is not allowed to be used as the second byte. Sequences of programming procedure are published in the appropriate device data sheets. The remaining codes have not been fixed and devices must ignore these codes. When B is a 1, the 2-byte sequence is a hardware general call. This means that the sequence is transmitted by a hardware master device, such as a keyboard scanner, which cannot be programmed to transmit a desired slave address. Since a hardware master does not know in advance to which device the message must be transferred, it can only generate this hardware general call and its own address, thereby identifying itself to the system, figure 13. The 7 bits remaining in the second byte contain the device address of the hardware master. This address is recognized by an intelligent device, such as a microcomputer, connected to the bus, which will then direct the information coming from the hardware master. If the hardware master can also act as a slave, the slave address is identical to the master address. In some systems, an alternative could be that the hardware master transmitter is brought in the slave receiver mode after the system reset. In this way, a system configuring master can tell the hardware master transmitter, which is now in slave receiver mode, to which address data must be sent, figure 14. After this programming procedure, the hardware master remains in the master transmitter mode. Start byte. Microcomputers can be connected to the 12C bus in 2 ways. If an on-chip hardware 1C2 bus interface is present, the microcomputer can be programmed to be interrupted only by requests from the bus. When the device possesses no such interface, it must constantly monitor the bus via software. Obvious. December 1988. 8. SOAI master address 1 AI data AIP. 11. General second, and bytes plus acknowledge. Call address byte. Figure 13. Data transfer from hardware master transmitter. ISI slave A address /U master R /WIAI dump address for /U master IXIAP. Right. A. Configuring master sends dump address to hardware master. S dump address from H/W master IR /WIAI data IAP. I12. Write in bytes plus acknowledge. B. Hardware master dumps data to selected slave device. Figure 14. Data transfer of hardware master transmitter capable of dumping data directly to slave devices. 22. I2UMMY I2SDA. I \acknowledge. II2, hi, I. SCLTJ //0. R, backslash. I, backslash. I, backslash. JTI. I underscore I backslash dot J backslash dot J. Backslash dot J. Backslash dot GCK backslash dot JI underscore I. LS dot J LSR dot J. Dash start BYTEOCL00001 dash backslash. Figure 15. Start byte procedure. E. The more times the microcomputer monitors, or polls, the bus, the less time it can spend carrying out its intended function. Therefore, there is a difference in speed between fast hardware devices and the relatively slow microcomputer which relies on software polling. In this case, data transfer can be preceded by a start procedure which is much longer than normal, figure 15. The start procedure consists of a start condition, s. b. A start byte 00000001. c. An acknowledge clock pulse. d. A repeated start condition, senior. After the start condition, s, has been transmitted by a master requiring bus access, the 3 to 10 start byte 00000001 is transmitted. Another microcomputer can therefore sample the SDA line on a low sampling rate until one of the 7 zeros in the start byte is detected. After detection of this low level on the SDA line, the microcomputer is then able to switch to a higher sampling rate in order to find the second start condition, senior, which is then used for synchronization. A hardware receiver will reset at the reception of the second start condition, senior, and will therefore ignore the start byte. After the start byte, an acknowledge related clock pulse is generated. This is present only to conform with the byte handling format used on the bus. No device is allowed to acknowledge the start byte. Synthetix linear products. 1C2 bus specification. III. ISI underscore 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 dash. II. SCL. II. 2 II. Olin I2. Dash ILJLJJL underscore 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 ILJJ star condition SSR colon INDATA bits low LSE colon K related clock pulse. Figure 16. Data format of transmissions with CBUS receiver/transmitter. CBUS compatibility. Existing CBUS receivers can be connected to the 12C bus. In this case, a third line called DLEN has to be connected and the acknowledge bit omitted. Normally, 12C transmissions are multiples of 8-bit bytes. However, CBUS devices have different formats. In a mixed bus structure, 12C devices are not allowed to respond on the CBUS message. For this reason, a special CBUS address 00000TX has been reserved. Number 12C device will respond to this address. After the transmission of the CBUS address, the DLEN line can be made active and transmission according to the CBUS format, can be formed, figure 16. After the stop condition, all devices are again ready to accept data. Master transmitters are allowed to generate CBUS formats after having sent the CBUS address. Such a transmission is terminated by a stop condition, recognized by all devices. In the low-speed mode, full 8-bit bytes must always be transmitted and the timing of the DLEN signal adapted. If the CBUS configuration is known and no expansion with CBUS devices is foreseen, the user is allowed to adapt the hold time to the specific requirements of device used. Electrical specifications of inputs and outputs of 12C devices. The 1C2 bus allows communication between devices made in different technologies which might also use different supply voltages. For devices with fixed input levels, operating on a supply voltage of +SV plus or minus 10%, the following levels have been defined. VIL max equals 1.SV, maximum input low voltage. December 1988. VDD1-4 equals 5 VT 10%. S L plus plus Figure 17. Fixed input level devices connected to the 12C bus. VDD equals EG3V. RR. S plus L plus Figure 18. Devices with a wide range of supply voltages connected to the 12C bus. VIMN equals SV, minimum input high voltage. Devices operating on a fixed supply voltage, different from +SV, e.g. 12L, must also have these input levels of 1.SV and SV for VIL and VIH, respectively. For devices operating over a wide range of supply voltages, e.g. CMOs, the following levels have been defined. VIL max equals O.SVU, maximum input low voltage. VIMN equals 0.7 VU, minimum input high voltage. For both groups of devices, the maximum output low value has been defined. Vol max equals OAV, maximum output voltage low. At SMA sync current 3 to 11, the maximum low-level input current at vol max of both the SDA pin and the SCL pin of an 1C2 device is -10/law, including the leakage current of a possible output stage. The maximum high-level input current at 0.9 VU of both the SDA pin and SCL pin of an 1C2 device is 10/law, including the leakage current of a possible output stage. The maximum capacitance of both the SDA pin and the SCL pin of an 1C2 device is 10 pF. Devices with fixed input levels can each have their own power supply of +5 V plus or minus 10%. Pull-up resistors can be connected to any supply. See Figure 17. However, the devices with input levels related to VU must have one common supply line to which the pull-up resistor is also connected. See Figure 18. Synthetix linear products. 1C2 bus specification. When devices with fixed input levels are mixed with devices with VU-related levels, the latter devices have to be connected to one common supply line of +5 V plus or minus 10% along with the pull-up resistors, Figure 19. Input levels are defined in such a way that 1. The noise margin on the low level is 0.1 V. 2. The noise margin on the high level is 0.2 V. 3. Series resistors, Rs, up to 300 N can be used for flashover protection against high voltage spikes on the SDA and cell line. Due to flashover of a TV picture tube, for example, Figure 20. The maximum bus capacitance per wire is 400 pF. This includes the capacitance of the wire itself and the capacitance of the pins connected to it. Timing. The clock on the 12E bus has a minimum low PNO of 4.7/1s and a minimum high period of 4/1s. Masters in this mode can generate a bus clock with a frequency from 0 to 100 kHz. All devices connected to the bus must be able to follow transfers with frequencies up to 100 kHz, either by being able to transmit or receive at that speed or by applying the clock synchronization procedure, which will force the master into a wait state and stretch the low PNOs. In the latter case, the frequency is reduced. Figure 21 shows the timing requirements in detail. A desktop of the abbreviations used is shown in Table 2. All timing references are at VLMAX and VLMLO. VDDISVTIO %V0D2 equals 5 VT10% VDD3 equals 6 VT10%. Lip RP S dash 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 underscore 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 L plus dash 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 plus dash dash plus. Figure 19. Devices with VU-related levels mixed with fixed input level. Devices on the IC bus. LVDD. IDCEI IDCEI. RRRRRPRP. S. L. LD05650S. Figure 20. Serial resistors, RSL, for protection against high voltage. Low speed mode. As explained previously, there is a difference in speed on the 12E bus between fast hardware devices and the relatively slow micro computer, which relies on software polling. For this reason, a low speed mode is available on the 1x10^2 bus to allow these microcomputers to poll the bus less often. Start and stop conditions. In the low speed mode, data transfer is preceded by the start procedure. Data format and timing. The bus clock in this mode has a low period of 130/1s plus or minus 25/1s and a high period of 390/1s plus or minus 25/1s, resulting in a clock frequency of approximate 2 kHz. The duty cycle of the clock has this low to high ratio to allow for more efficient use of microcomputers without an on-chip hardware 1x10^2 bus interface. In this mode also, data transfer with acknowledge is obligatory. The maximum number of bytes transferred is not limited. Figure 22. Figure 21. Timing requirements for the 12C bus. December 1988 3-12. Synutix Linear Products. 1C2 bus specification. Table 2. Timing requirement for the 12C bus. Limits. Symbol parameter. Min-max. FSCL SCL clock frequency 0-100. T bulletin F time. The bus must be free before a new transmission can start. 4.7. Though, STA hold time start condition. After this PNO, the first clock pulse is generated for TLOW the low period of the clock 4.7. THIGH the high period of the clock 4. XU. STA setup time for start condition, only relevant for a repeated start condition, 4.7. Though. OUT hold time data. For CBUS compatible masters 5. For 1C2 devices O. XU. OUT setup time data 250. TR rise time of both SDA and SCL HNIS 1. TF fall time of both SDA and SCL lines 300. XU, STO setup time for stop condition 4.7. Notes. All values referenced to VIH and VIL levels. Asterisk note that a transmitter must internally provide a hold time to bridge the undefined region, 300 ns max, of the fall hung edge of cell. SOA. 8 CLI. III. III. IITTD, SRA- RI. LS. December 1988. Figure 22. Data transfer low speed mode. IHLGHI. Figure 23. Timing low speed mode. 3 to 13. Unit. Kilohertz. PS, 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 NS. PS, NS. PS, Synutix linear products. 1C2 bus specification. Low speed mode. Clock. Duty cycle. Start byte. Max. No. Of bytes. Premature termination of transfer. Acknowledge clock bit. Acknowledgement of slaves. Table 3. Timing low speed mode. Symbol. TLOW equals 130 L1S plus or minus 2511s. THIGH equals 390 L1S plus or minus 2511s. 1:3 low to HLGH, duty cycle of clock generator 00000001. Unrestricted. Not allowed. Always provided. Obligatory. Parameter. TSUF time the bus must be free before a new transmission can start. In this mode, a transfer cannot be terminated. During the transmission of a byte, the bus is considered busy after the first start. Condition it is considered free again 1. Minimum clock low period, 10,511s, after the detection of the stop condition. Figure 23. Shows the timing requirements in detail, table. 3 explains the abbreviations. Limits. Unit. Min-max. 105 I1s. Though, STA hold time start condition. After this period the first clock pulse is generated 365 is. Though, STA hold time, repeated start condition only, 210 I1s. TLOW the low pano of the clock 105 155 I.is. THIGH the high period of the clock 365 415 I1s. XU. STA setup time for start condition, only relevant for a repeated start condition, 105 155 I1s. Though, toad hold time data. For CBUS compatible masters 5 I1s. For 12C devices O I1s. XU. OUT setup time data 250 ns. TR rise time of both SDA and SCL lines 1 I1s. TF fall time of both SDA and SCL lines 300 ns. XU, STO setup time for stop condition 105 155 I1s. Notes. All values referenced to VIH and VIL levels. Asterisk note that a transmitter must internally provide a hold time to bridge the undefined region, 300 ns max, of the Fallhang edge of SCL. December 1988 3-14. Synthetix Linear Products. 1C2 Bus Specification. Appendix A. Maximum and minimum values of the pull-up resistors RP and series resistors Rs, C. Figure 20. In a 1C2 bus system, these values depend on the following parameters: supply voltage, bus capacitance, number of devices, input current plus leak, age current. 8. 1. The supply voltage limits the minimum value of the RP resistor to the specified 3 mA as minimum. Sink current of the output stages at OAV as maximum low voltage. In graph 1, VU against RPM, IS. Shown. //:vmax.rs. 9. 1218. Graph 1. The desired noise margin of 0.1 VU for the low level limits the maximum value of Rs. December 1988. In graph 2, Rs max against RPIS shown. 2. The bus capacitance Is the total Ca. Capacitance of wire, connections, and pins. This capacitance limits the maximum value of RP because of the specified rise time of 111s. 20. Maximum VAWER, Q. Graph 2. // R equals O. Max. At VUSI. Dash equals 100 200 300. Bus capacitance, PF. Graph 3. 3-15. In graph 3, the bus capacitance, ARP max relationship is shown. 3. The maximum high-level input current of each input/output connection has a specified value of 101 La max. Due to the desired noise margin of 0.2 VU. For the high level, this input current limits the maximum value of RP. This limit is dependent on VU. In graph 4, the total high-level input current, ARP max relationship is shown. 20. 18. RL. W12. 3. IE. IE. LOTAL high-level input current, J.A. Graph 4. 12C license. Purchase of Synthetix or Philips 1C2 components conveys a license under the Philips 1C2 patent and GHTS to use these components in an 1C2 system, provided that the system conforms to the 12C standard specification as defined by Philips. Synthetix. Linear Products. Author, Carl Fenger. Introduction. The 12C, Inter-IE, bus is becoming a popular concept which implements an innovative serial bus protocol that needs to be understood. On the hardware level, 12C is a collection of microcomputers, MAV 8400, PCD 3343, 83C351, 84CXX, and peripherals, LCD/LED. Drivers, RAM, ROM, clock/timer, A/D, D/A. IR transcoder, I/O, DTMF generator, and various tuning circuits that communicate serial over a 2-wire bus, serial data, SDA, and serial clock, SCL. The 12C structure is optimized for hardware simplicity. Parallel. Address and data buses inherent in conventional systems are replaced by a CENL proto-COL that transmits both address and bidirectional data over a two-line bus. This means that interconnecting wires are reduced to a minimum, only V, ground, and the two-wire bus are required to link the controller, S, with the peripherals or other controllers. This results in reduced chip size, pin count, and interconnect ions. N12C system is therefore smaller, simpler, and cheaper to implement than its parallel counterpart. The data rate of the 12C bus makes it suited for systems that do not require high speed. N12C controller is well suited for use in systems such as television controllers, telephone sets, appliances, displays, or applications involving human interface. Typically an 12C system might be used in a control function where digitally controllable elements are adjusted and monitored via a central processor. SOR. The 12C bus is an innovative hardware interface which provides the software designer the flexibility to create a truly multi-master environment. Built into the serial interface of the controllers are status registers which monitor all possible bus conditions, bus frequency, busy, bus contention, slave acknowledgement, and bus interference. Thus in 12C and 168, the inter-integrated circuit, PC, serial bus, theory and practical consideration. Application note. Edgement on every byte also facilitates data integrity. N12C system can be as simple or sophisticated as the operating environment demands. Whether in a single master or multi-master system, noisy or safe, correct SYS TEM operation can be ensured under software controllers. Currently the family of 12C controllers include the MAV 8400 and the PCD 3343, the PCD 3343 is basically a CMOS version of the MAV 8400. The MAV 8400 is based on the 8048 architecture with the 12C interface built in. The instruction set for the MAV 8400 is similar to the 8048, with a few instructions added and a few deleted. Tables 1 and 2 summarize the differences. Programs for the MAV 8400 and PCD 3343 may be assembled on an 8048 assembler using the macros listed in Appendix A. The CENL I/O instructions involve moving data to and from the SO, S1, and S2 serial I/O control registers. The block diagram of the 12C interface is shown in Figure 1. Serial 1/0 interface. A block diagram of the CENL input/output SIO is shown in Figure 1. The clock line of the serial bus, SCL, has exclusive use of pin 3, while the CENL data, SDA, line shares pin 2 with parallel I/O signal P23 of port 2. Consequently, only 3 I/O lines are available for port 2 when the 12C interface is enabled. Communication between the microcomputer and interface takes place via the internal bus of the microcomputer and the serial interrupt request line. 4 registers are used to store data and information controlling the operation of the interface. Data shift register SO, address register SO, status register S1, Clock control register S2. The 12C bus interface. Serial control registers. So, S1. All serial 12C transfers occur between the accumulator and register so. The 12C hardware takes of clocking out / in the data. And reselvlowing / generaling and acknowledge. In addition, the state of the 12C bus is controlled and monitored via the bus control register S1. A definition of the registers is as follows. Data shift register so is the data shift register used to perform the conversion between serial and parallel data format. All transmissions or receptions take place through register so MSB first. All 12C bus receptions or transmissions involve moving data to / from the accumulator from to so. Table 1_MAB 8400 family instructions not in the MAB 8048 instruction set. Serial 1/0 register control. Conditional branch. MOVASN DEC at RR cell MB2JNTF address. MOVSN a DJNZ at RR address cell MB3. MOVSN hashtag data. NSI. DisSI. System might include several controllers on table 2_MAB 8048 instructions not in the MAB 8400 family instruction set. The same bus each with the ability to asynchronously communicate with peripherals or each other. This provision also provides expandability for future add-on controllers. The 12C system is also ideal for use in environments where the bus is subject to noise. Distorted transmissions are immediately detected by the hardware and the information presented to the software. A slave acknowledge. Data moves. MOVXA at R. MOVX at RA. MOVP3A at A. MOVDAP. MPVDPA. ANLDPA. ORLDPA. December 1988 3-16. Flags branch control. CLRFOJNI address ENTOCLK. CPLFOJFO address. CLRF1JF1 address. CPLF1. Replaced by JTO, JNTO. Signatix linear products. The inter-integrated circuit, 12C, serial bus. Theory and practical consideration. INMALIZE. Pin 17. O reset. T. LRB. WRSO. RDSO. Application node. 8400. Interrupt. Logic. Pin. N168. Intrio. ENSI. DISI. Internal microcomputer bus. Bit 7. WRS1. MSTTRXBB. RDS1. S1. Clock. Serial clock pulse generator baud. Counter 1-- internal clock. Figure 1. Block diagram of the MAB 8400-510 interface. Address register so, in multi-master systems, this register is loaded with a controller's slave address. When activated, ALS equals 0, the hardware will recognize when it is being addressed by setting the AAS addressed as slave flag. This provision allows a master to be treated as a slave by other masters on the bus. Status register 51, S1 is the bus status register. To control the SIO interface, information is written to the register. The lower 4 Bits in S1 serve dual purposes, when written. 2. The control bits SO, BC2, BC1, BCOR. Programmed, enable serial output and a 3-bit counter which indicates the current number of bits left in a serial transfer. When reading the lower 4 bits, we obtain the December 1988 status information AL, AAS, ADO, LRB, RBI. Tration lost, addressed as slave, address 0, the general call has been received, the last received bit, usually the acknowledge bit. The upper 4 bits are the MST, TRX, BB, and pin control bits, master, transmitter, bus, busy, and pending interrupt not. These bits define what role the controller has at any particular time. The values of the master and transmitter bits define the controller as either a master or slave. A master initiates a transfer and generates the serial clock, a slave does not, and as a transmitter or receiver. Bus busy keeps track of whether the bus is free or not, and is set and reset by the start and stop conditions which will be defined. Pending interrupt not is reset after the completion 3 to 17 of a byte transfer plus acknowledge, and can be polled to indicate when a serial transfer has been completed. An alternative to polling the pin bit is to enable the serial interrupt. Upon completion of a byte transfer, an interrupt will vector program control to location 07H. Serial clocky acknowledge. Control register S2. Register S2 contains the clock control register and acknowledge mode bit. Bits S20, S24 program the bus clock speed. Bit 826 programs the acknowledge or not AC. Knowledge mode 1/0. The various 1C2 bus clock speed possibilities are shown in Table 3. Synutics linear products. The inter-integrated circuit, 1-2C, serial bus. Theory and practical consideration. Table 3. Clock pulse. Frequency control. When using a 4.43 MHz crystal hex approximate S20 S24 divisor FCLOCK. Code, kilohertz. 0 not allowed. 139 114. 245 98. 351 87. 463 70. 575 59. 687 51. 799 45. 8 123 36. 9 147 30. A 171 26. B 195 23. C 243 18. D 291 15. E 339 13. F 387 11. 10 483 9.2. 11 579 7.7. 12 675 6.6. 13 771 5.8. 14 963 4.6. 15 1155 3.8. 16 1347 3.3. 17 1539 2.9. 18 feet 1923 inches 2.3. 19 feet 2307 inches 1.9. La 2691 1.7. LB 3075 1.4. LC 3843 1.2. 104611 1.0. IE 5379 0.8. IF 6147 0.7. Only values that may be used in the low speed mode. ASC1. These speeds represent the frequency of the serial clock bursts and do not reflect the speed of the processor's main clock, i.e. it controls the bus speed and has no effect on the CPU's execution speed. Bus arbitration. The losing master is now configured as a slave which could be addressed during this very same cycle. These provisions allow for a number of microcomputers to exist on the same bus with properly written subroutines. Software for any one of the controllers may regard other masters as transparent. 12C Protocol N. Assembly language. Examples. 12C data transfers follow a well-defined protocol. A transfer always takes place between a master and a slave. Currently a microcomputer can be master or slave, while the clips peripherals are always slaves. In a bus IRE condition, both SCL and SDA lines are kept logical high by external pull-up resistors. All bus transfers are bounded by a start and a stop condition. A start condition is defined as the SDA line making a high to .IOW transition while the cell line is high. At this point, the internal hardware on all slaves are activated and are prepared to clock in the next 8 bits and interpret it as a 7-bit address and a R/W control bit, MSB first. All slaves have an internal address, most have 2 to 3 programmable address bits, which is then compared with the received address. The slave that recognized its address will respond by pulling the data line low during a 9th clock generated by the master. All 12C byte transfers require the master to generate 8 clock pulses plus a 9th acknowledge related clock pulse. The slave acknowledge will be tiered by the master as a 0 appearing in the LRB, last received bit, position of the 51 serial IO status register. If this bit is high, MAB 8400 SCL SOA PCF 8574 AO IO expander address equals 40H application node N168. After a transfer attempt, this indicates that a slave did not acknowledge, and that the transfer should be repeated. After the desired slave has acknowledged its address, it is ready to either send or receive data in response to the master's driving clock. All other slaves have withdrawn from the bus. In addition, for multi-master systems, the start condition has set the bus busy bit of the serial IO register 51 on all masters on the bus. This gives a software indication to other masters that the bus is in use and to wait until the bus is free before attempting an access. There are 2 types of 12C peripherals that now must be defined. There are those with only a chip address such as the IO expander, PCF8574, and those with a chip address plus an internal address such as the static RAM, PCF8570. Thus after sending a start condition, address, and R/W bit, we must Take into account what type of slave is being addressed. In the case of a slave with only a chip address, we have already indicated its address and data direction, r/w, and r. Therefore ready to send or receive data. This is performed by the master generating bursts of 9 clock pulses for each byte that is sent or received. The transaction for writing 1 byte to a slave with a chip address only is shown in Figure 3. In this transfer, all bus activity is invoked by writing the appropriate control byte to the serial I/O control register SI, and by moving data to / from the serial bus buffer register so. Coming from a known state, MOVSI #18H. Slave, receiver, bus not busy, we first load the serial I/O buffer so with the desired PCB 8570 Vs. RAM, L28 byte. Address equals AOH. Due to the wire and configuration of the 12C bus, and the self-synchronizing clock circuitry of 12C masters, controllers with varying clock speeds can access the bus without clock contention. During arbitration, the resultant clock on the bus will have a low period equal to the longest of the low periods. The high period will equal the shortest of the high periods. Similarly, when two masters attempt to drive the data line simultaneously, the data is and the master generating a low while the other is driving a high will win arbitration. The resultant bus level will be low, and the loser will withdraw from the bus and set its arbitration lost flag, 51-bit 3. Figure 2. Schematic for assembly examples. December 1988 3-18. Synthetix under Products Application Note. The Inter-Integrated Circuit, 12C, Serial Bus. N168. Theory and Practical Consideration. Plus. MOVSL #18H, initialize SL slave, receiver, bus not busy, enable serial 1/0. MOV so #40H, preload so with SIOV's address and r/w bit. MOVSL #8H, invoke start condition and slave address. Master, transmitter, bus busy, enable serial 1/0, bit counter equals 000. Check for transmission complete, AC. Received, no arbitration, etc. Call AutoIt. MOVA #2AUT, get a data byte. MOV so.a. Call AutoIt. Transmit data byte. MOV S1 #OD8H______, J. Wait for transmission complete again. Generate stop condition. Sieves address, MOV so #40H. To transmit. This preceded by a start condition. Must. First examine the control register S1. Which, after initialization, looks like this. Lias _ ter. M _ pin EADIC2 bet 8 co. 10/0101111110101. To transmit to a slave. The master. Transamelt. Tar. Bus busy. Pin, pending interrupt not. And SO, enable serial output, must be set to a 1. This results in an F6H being written to S1. This word defines the controller as a master transmitter, invokes the transfer by setting the bus busy bit, clears the pending Interrupt not, an inverted flag indicating the completion of a complete byte transfer, and activate as the serial output logic by setting the enable serial output, SO, bit counter S12, S11, S10, BC2, BC1, and BCO comprise a bit counter, which indicates to the logic how long the word is to be clocked out over the serial data line. By setting this to O_RTLIT. December 1988. Master, transmitter, bus not busy. Figure 3. To produce 9 clocks, 8 bits plus an acknowledge edge clock, for this transfer, the bit counter will then count off each bit as it is transmitted. The bit counter possibilities are shown in Table 4. Thus the bit counter keeps track of the number of clock pulses remaining in a serial transfer. Additionally, there is a not acknowledge edge mode, controlled through bit 6 of clock control register 52, which inhibits the AC knowledge clock pulse, allowing the possibility of straight serial transfer. We may thus define the word size for a serial transfer by preloading BC2, BC1, BCO with the appropriate 8 control number, WFTH or without an ACK. Notage related clock pulse being generated. This makes the controller able to transmit serial data to most any serial device regard less of its protocol, e.g. C-bus devices. Checking for slave acknowledge. After a star, condel tickn and address have been issued, the selected sieve will have recognized and acknowledged its address by Table 4. Binary numbers in bit count locatlana BC2, BC1, and BCO. B2, B1, BCO. Bit/byte. Without ACK with ACK. 00112. 01023. 01134. 10045. 10156. 11067. 11178. 00069. 3 to 19. Synutics on-ear products. The inter-integrated circuit, 12C, serial bus. Theory and practical consideration. Pulling the data line low during the 9th clock pulse. During this period, the software, which runs on the processor's 4 MHz clock, will have been either waiting for the transfer to be completed by polling the pin bit in 51, which goes low on completion of a transfer/reception, whose length is defined by the pre-loaded bit counter value, or by the hardware. In serial interrupt mode, the serial interrupt, vectored to 07H, is enabled via the N51. Enable serial interrupt instruction. AutoIt, MOVASI. JB4 AutoIt. JBO bus air. RET. Get bus status word. From 51. Poll the pin bit until it goes low, indicating transfer completed. Jump to bus air. Routine if acknowledge not received. Application note. N168. Transfer complete. Acknowledge received, return. At the point when pin goes low, or the sentinel interrupt is received, the 9BLT transfer has been completed. The acknowledgement bit will now be in the LRB position of register 51, and may be checked in the routine AutoIt. Wait for acknowledge, as shown in Figure 4. Figure 4. This routing must go one step further in multi Master systems, the possibility of an arbitration loss situation may occur if other masters are present on the bus. This condition may be detected by checking the AL bit, bit 3. If arbitration has been lost, provisions for attempting the transmission should be taken. If arbitration is lost, there is the possibility that the controller is being addressed as a slave. If this condition is to be recognized, we must test on the AAS bit, bit 2. A general call address, O, has also been defined as an all call address for all slaves, bit I, ado. Must be tested if this feature is to be recognized by a master. After a successful address transfer / acknowledge, the slave is ready to be sent its data. The instruction mov SOA will now automatically send the contents of the accumulator out on the bus. After calling the AutoIt routine once more, we are ready to terminate the transfer. The stop condition is created by the instruction mov51, #od8h. This sets the bus busy bit, which tells the hardware to generate a stop. The data line makes a low to high transition while the clock remains high. All bus busy flags on other masters on the bus are reset by the signal. The transfer is now complete. PCF8574 IO expander will transfer the SENL data stream to its 8 output pins and latch them until further update. December 1988. Master reads 1 byte from slave. A read operation is a similar process. The address, however, will be 41H, the LSB, indicating to the I/O device that a read is to be performed. Dung the data portion of a read, the I/O port 8574 will transmit the contents of its latches in response to the clock generated by the master. The master / receiver in this case generates a low-level acknowledge on reception of each byte, a positive acknowledge. Upon completion of a read, the master must generate a negative acknowledge dung the 9th clock to indicate to the slaves that the read operation is finished. This is necessary because an arbitrary number of bytes may be read within the same transfer. A negative acknowledge consists of a high signal on the data line during the 9th clock of the last byte to be read. To accomplish this, the master 8400 must leave the acknowledge mode just before the final byte, read the final byte, producing only 8 clock pulses, program the bit counter with 001, prepare for a 1-bit negative AC knowledge pulse, and simply move the contents of SO to the accumulator. This final instruction accomplishes two things simultaneously. It transfers the final byte to the accumulator and produces 1 clock pulse on the SCL line. The structure of the serial I/O register SO is such that a read from it causes a double buffered transfer from the 1C2 bus to SO, while the original contents of SO are transferred to the accumulator. B. Cause the number of clocks produced on the bus is determined by the control number in the bit counter, by presetting it to 001, only 3 to 20. 1 clock is generated. At this point in time, the slave is still waiting for an acknowledge. The bus is high due to the pull-up, as single clock pulse in this condition is interpreted as a negative acknowledge. The slave has now been informed that reading is completed. A Stop condition is now generated as before. The read process, 1 byte from a slave with only a chip address, is shown in figure 5. Syntactics linear products. The inter-integrated circuit, 12C, serial bus. Theory and practical consideration. SCL. Isteen. ICONDMON. Wait. December 1988. AD. Acknowledge. MOVS1 hashtag 18H. MOVSO hashtag 41H. MOVS1 hashtag of 8H. Call AutoIt. MOV. S2 hashtag 0I. MOVSOA. MOVAS1. JB4 wait. MOVS1 hashtag OA9H. MOVASO underscore. MOVS1 hashtag OD8H J. Initialize serial 1/0 control. Register. Preload serial register SO. With slave address and RD. Control bit. Send address to bus along with. Start condition. Wait for acknowledge, as before. Leave acknowledge mode. Read data from slave to SO. Test for byte received by. Testing S1 pin bit. Wait until pin received. Set bit counter to 1 and become a receiver, A9 equals. MST rec bus busy bit Kuttner equals 001. Move data to accumulator and clock out a negative. Acknowledge. Generate stop condition. Figure 5. 3 to 21. Application note. N168. I stop. I condition. I. Syntactics linear products application note. The inter-integrated circuit, 12C, serial bus. N168. Theory and practical consideration. Co-NLCATION with peripheral required. MOVS1 hashtag 18H, initialize bus status register. Master, transmitter. Bus not busy, enable SIO. MOVSO, hashtag OAOH, load SO with RAM's chip. Address. MOVSI, hashtag of 8H, start condo and transmit. Address. Call AutoIt, wait until address received. MOVA hashtag O, set up for transmitting RAM. Ilocation address. MOVSOA, transmit first RAM address. Call AutoIt, wait. MOVS1 hashtag 18H, set up for a repeated start. Condition. MOVA hashtag OA1H, get RAM chip address and RD bit. MOVSOA, send out to bus. MOVS1 hashtag of 8H, preceded by repeated start. Call AutoIt, wait. MOVSO, first data byte to SO. Call AutoIt, wait. MOVSO, second data byte to SO. And first data byte to ACC. Call AutoIt, wait. MOVROA, save first byte, RO. MOVSO, third data byte to SO. And second data byte to ACC. Call AutoIt, wait. MOVR1A, save second data byte. In RI. MOVS2 hashtag 01H, leave ACK. Mode. BLT counter equals OOL for NEG ACK. MOVSO, third data byte to ACC. Negative ACK. Generated. MOVR2A, save third data byte in R2. Wait 1, MOVA ST, get bus status. JB4WAITT, wait until transfer complete. MOVSI hashtag OD8H, stop condition. MOVS2 hashtag 41H. Restore acknowledge mode. Figure 8. Flowchart for reading/writing 1 byte to and 12 figure 7. Peripheral, Slongal Ma 8 tur, SLNG. Adria slave. These examples apply to a slave with a chip. Address, more than 1 byte can be read. 10/read within the same transfer, however. This option is more applicable to 12C devices. With sub-addresses such as the static RAMs or clock/calendar. In the case of these types of devices, a slightly different protocol is used. The RAM, for example, requires a chip address and an internal memory location before it can deliver or accept a byte of information. During a write operation, this is December 1988. Done by simply writing the secondary address. Right after the chip address, the peripheral is designed to interpret the second byte as an internal address. In the case of a read operation, the slave peripheral must send data back to the master after it has been addressed and sub-addressed. To accomplish this, first the start address and sub address is transmitted. Then we have a repeated start condition to reverse the direction of the data transfer, followed by the chip 3 to 22 address and RD, then a data string, W/. Acknowledges. This repeated start does not affect other peripherals, they have been deactivated and will not reactivate until a stop condition is detected. 12C peripherals are equipped with auto-incrementing logic, which will automatically transmit or receive data in consecutive, increasing occasions. For example, to read 3 consecutive bytes to PCB 8571 RAM locations 00, 01, and 02, we use the following format as shown in Figure 7. Signatix linear products. The inter-integrated circuit, 12C, serial bus. Theory and practical consideration. This routine reads the contents of location 00, 01 and 02 of the PCB 8571 128-byte RAM and puts them in registers R0, R1, and R2. The auto-incrementing feature allows the programmer to indicate only a starting location, then read an arbitrary block of consecutive memory addresses. The wait one loop is required to poll for the completion of the final byte because the AutoIt routine will not recognize the negative acknowledge as a valid condition. December 1988. Bus error conditions. Acknowledge not received. In the above routines, should a slave fall to acknowledge, the condition is detected during the AutoIt routine. The occurrence may indicate one of two conditions: the slave has failed to operate, or a bus disturbance has occurred. The software response to their event is dependent on the system application. In either case, the bus error routine should reinitialize the bus by issuing a stop condition. Provision may then be taken to 3 to 23. Application note. N168. Repeat the transfer an arbitrary number of times. Should the symptom persist, either an error condition will be entered, or a backup device can be activated. These sample routines represent single master systems. A more detailed analysis of multi-master/noisy environment systems will be treated in further application notes. Examples of more complex systems can be found in the Software Examples Manual, publication 9398 615 70011. I. Synthetix Linear Products Application Note. The Inter-Integrated Circuit, 12C, Serial Bus. N168. Theory and Practical Consideration. Appendix A. Only the 8048 assembler is capable of assembling MAB 8400 source code when it has at least a data or defined byte assembly or directive, possibly in combination with a macro facility. Macro definitions. Line 1 macrofill. The new instructions can be simply defined by macros. The instructions which are not in the MAB 8400 should not be in the MAB 8400 source program. An example of a macro definitions list is given here for the Intel macro assembler. This list can be copied in front of a MAB 8400 source program. The new instructions are added to the MAB 8400 source program by calling the macro via its name in the op code field and, if required, followed by an operand in the operand field. Source statement. 2. Macros for 8048 assembler recognition. 3. Of 8400 commands. 4 movso. 5 db3ch. 6 enom. 7 movaso. 8 dboc. 9 endm. 10 movs1a. 11 db3dh. 12 endm. 13 movazi. 14 dbo. 15 endm. 16 movs2a. 17 db3et. 18 endm. 19 movso. 20 db9chl. 21 endm. 22 movsl. 23 db9dhl. 24 endm. 25 movs2. 26 db9ll. 27 endm. 28 ensi. 29 db85h. 30 endm. 31 disi. 32 db. 33 endm. 34. 35, port 0 instructions. 36, INAPO. 37 db. 38 endm. 39. 40 outpa. 41 db. 42 endm. 43. 44 orlpo. 45 db. 46 endm. 47. 48 enpo. 49 db. 50 endm. 51. December 1988 3-24. Macro. 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 Macro L. Macro L. Macro L. Macro. Macro. 95H. Macro. 08H. Macro. 38H. Macro L. 88HL. Macro L. 98HL. MOVSOA. MOVASO. MOVSIA. MOVASI. MOVS2A. MOVSO hashtag data. MOVSI hashtag data. MOVS2 hashtag data. NSI. DisSI, disable serial. Interrupt. In APO. OUTLPO A. ORLPO hashtag data. ANLPO hashtag data. Synthetix Linear Products Application Note. N168. The Inter-Integrated Circuit, 12C, Serial Bus. Theory and practical consideration. Macro definitions, continued. Line source statement. December 1988. 52, data memory instructions. 53. 54. 55. 56. 57. 58. 59. 60. 61, select memory bank instructions. 62. 63. 64. 65. 66. 67. 68. 69. 70, conditional jump instructions. 71. 72. 73. 74. 75. 76. 77. 78. 79. 80. 81. 82. 83, end of macro definitions. Decaro. DB. ENDM. Decar1. DB. ENDM. Selm2. DB. ENDM. Selm3. DB. ENDM. Oinzeo. DB. ENDM. Oinza1. DB. ENDM. JNTF. DB. ENDM. 3 to 25. Macro. OCOH. Macro. OC1H. Macro. OA5H. Macro. OB5H. Dec at RO. Dec at R1. Cell MB2. Cell MB3. Macro L, DJNZ at RO address. OEOHL and OFFH. Macro L, DJNZ at R1 address. OE1HL and OFFH. Macro L, jump if timer flag is non-zero. 06HL and OFFH. Synthetix Linear Products Application Node. The Inter-Integrated Circuit, 12C, Serial Bus. N168. Theory and Practical Consideration. The 8400 instructions built from the macro list. LOC/OBJ line source statement. 00001 org 0. 2 Movaso, macro for MOVASO. OOC3 plus DBOC. 4 MOVASL, macro for MOVASL. 00010D5 plus DBODH. 6 MOVSO, macro for MOVSOA. 00023C7 plus DB3CH. 8 MOVS1A, macro for MOVSLA. 00033D9 plus DB3DH. 10 MOVS2A, macro for MOVS2A. 00043 times 10 to the power of 11th plus DB3 at 12 MOVSO 56H, macro for MOVSO. Hashtag 56H. 00059C13 plus DB9CH 56H. 0000656. 14 MOVSL9FH, macro for MOVSL. Hashtag 9FH. 00079D15 plus DB9DH9FH. 00089F. 16 MOVS2OE8H, macro for MOVS2. Hashtag OE8H. 00099 times 10 to the power of 17th plus DB9 OE8H. 000AE8. 18 ENSL, macro for NSL. 000B8519 plus DB85H. 20 DSSI, macro for DSSI. 000C9521 plus DB95H. 22 INAPO, macro for INAPO. OOOD0823 plus DB08H. 24 output, macro for OUTL POE. OOOE3825 plus DB38H. 26 ORLPO5 macro for ORL POE. OOOF8827 plus DB88H5 00105A. 28 NPO2FH, macro for ANL POE. 00119829 plus DB98H2FH. 00122F. 30 Decaro, macro for DEC at RO. 0013 Co31 plus DBOCOH. 32 DECARL, macro for DEC at RL. 0014 CL33 plus DBOC1H. 34 SELM2, macro for cell MB2. 0015A535 plus DBOA5H. 36 SELM3, macro for cell MB3. 0016B537 plus DBOB5H. 38 OINZAO567H, macro for DJNZ at RO. 567H. 0017EO39 plus DBOEOH567HN. OFFH. 001967. 40 DJNZ ALAFI, macro for DJNZ at RL. AFI. 0019L41 plus DBOLHFEN. OFFH. 001AFA. 42 JNTF789H, macro for JNTF789H. 001B0643 plus DB06H, 789HN. OFFH. 001C89. 44 End. December 1988 3-26. Synotics. Linear products. Section 4. RF communications. Index. RF signal processing. Amplifiers. NE/SA5204. NE/SI. SE5205. NE/SE5539. N140. NE5592. NE/SE592. N141. Wideband high frequency amplifier. Wideband high frequency amplifier. Ultra high frequency operational amplifier. Compensation techniques for use with the NE/SE5539. Video amplifier. Video amplifier. Using the NE/SE592 video amplifier. Melser/modulators/demodulators. MC14961. 1596. N189. NE602. N1981. N1982. NE612. TDA1574. TDA5030A. IF systems. CA3089. MC3361. N1992. NE/SA604A. N1991. N1993. NE/SA605. NE614A. NE/SA615. TDA1576. Balanced modulator/demodulator. Balanced modulator ID modulator applications using the MC1496/MC1596. Double balanced mixer and oscillator. New low power single sideband circuits, NE602. Applying the oscillator of the NE602 in low power mixer applications. Low power VHF mixer tensillator. FM front end IC, VHF mixer and oscillator. VHF mixer oscillator, VHF tuner IC. FM IF system. Low power FMIV. Using the Synthetix MC3361 demonstration board. Low power FMIF system. Audio decibel level detector with meter driver. High sensitivity applications of low power. RF/IF integrated circuits. Low power FMIF system. Low power FMIF system. High performance low power mixer FMIF system. FMIF, quadrature detector. Single chip receivers. 4 to 3. 4 to 13. 4 to 24. 4 to 32. 4 to 38. 4 to 44. 4 to 53. 4 to 57. 4 to 61. 4 to 66. 4 to 72. 4 to 80. 4 to 83. 4 to 89. 4 to 95. 4 to 99. 4 to 105. 4 to 108. 4 to 114. 4 to 124. 4 to 126. 4 to 137. 4 to 141. 4 to 151. 4 to 156. NE/SA605 low power FMIF system. 4 to 137. NE/SA615 high performance low power mixer FMIF system. 4 to 151. TDA 7000 single chip FM radio circuit. 7 to 41. TDA 7010 single chip FM radio circuit, SO package. 7 to 77. 2. Frequency synthesis. Synthesizers. HEG 4750V. HEG 4751V. SAA 1057. N196. N197. Frequency synthesizer. 4 to 163. Universal divider. 4 to 173. PLL radio tuning circuit. 4 to 182. Single chip synthesizer for radio tuning. 4 to 190. Analysis and basic application of the SAA 1057. PLL radio tuning. 4 to 197. TDD 1742 CMOS frequency synthesizer. 4 to 209. Phase locked loops. ANL 77. N178. NE/SE564. N179. N180. N1801. N181. N182. NE/SE565. N183. N184. NE/SE566. N185. N186. NE/SE567. N187. N188. NE568. Companders. N174. N176. NE570/SA571. NE/SA572. N175. NE575. An overview of the phase locked loop, PLL. 4 to 222. Modeling the PLL. 4 to 227. Phase locked loop. 4 to 243. Circuit description of the NE564. 4 to 252. Frequency synthesis with the NE564. 4 to 259. 10.8 MHz FSK decoder with the NE564. 4 to 263. A 6 MHz FSK converter design example for the NE564. 4 to 266. Clock regenerator with crystal controlled phase locked. VCO, NE564. 4 to 268. Phase locked loop. 4 to 277. Circuit description of the NE565 PLL. 4 to 283. Typical applications with NE565. 4 to 287. Function generator. 4 to 290. Circuit description of the NE566. 4 to 295. Waveform generators with the NE566. 4 to 296. Tone decoder / phase locked loop. 4 to 299. Circuit description of the NE567 tone decoder. 4 to 311. Selected circuits using the NE567. 4 to 316. 150 MHz phase locked loop. 4 to 319. Applications for companders, NE570/571/SA571. Compander cookbook. Compander. Programmable analog compander. Automal C-level control using the NE572. Low voltage compander. 4 to 325. 4 to 334. 4 to 341. 4 to 348. 4 to 356. 4 to 357. Sinefix NE/SA5204. Wideband high frequency. Amplifier. Linear products. Description. The NE/SA5204 is a high frequency amplifier with a fixed insertion gain of 20 dB. The gain is flat to plus or minus 0.5 dB from DC to 200 MHz. The -3 dB bandwidth is greater than 350 MHz. This performance makes the amplifier ideal for cable TV applications. The NE/SA5204 operates with a single supply of 6V, and only draws 25 mA of supply current, which is much less than comparable hybrid parts. The noise figure is 4.8 dB in a 75.12 system and 6 dB in a 50.12 system. The NE/SA5204 is a relaxed version of the NE5205. Minimum guaranteed band width is relaxed to 350 MHz and the S parameter minimax limits are specified as typicals only. Until now, most RF or high frequency designers had to settle for discrete or hybrid solutions to their amplification problems. Most of these solutions required trade-offs that the designer had to accept in order to use high frequency gain stages. These include high power consumption, large component count, transformers, large packages with heat sinks, and high part cost. The NEI SA5204 solves these problems by porting a wideband amplifier on a single monolithic chip. The part is well matched to 50 or 75.12 input and output impedances. The standing wave ratios in 50 and 75.12 systems do not exceed 1.5 on either the input or output over the entire DC to 350 MHz operating range. Since the part is a small, monolithic IC die, problems such as stray capacitance are minimized. The die size is small. enough to fit into a very cost-effective 8-pin small outline, so, package to further reduce parasitic effects. Ordering information. Product specification. No external components are needed. Other than AC coupling capacitors because the NE/SA5204 is internally compensated and matched to 50 and 75.12. The amplifier has very good distortion. Specifications with second and THLRD. Order intermodulation intercepts of plus 24 dBm and plus 17 dBm, respectively, at 100 MHz. The part is well matched for 50.12 test. Equipment such as signal generators, oscilloscopes, frequency counters, and all kinds of signal analyzers. Other applications at 50.12 include mobile radio, CB radio, and data/video transmission in fiber optics, as well as broadband LANs and telecom systems. A gain greater than 20 dB can be achieved by cascading additional NE/SA5204S in series as required, without any degradation in amplifier stability. Features. Bandwidth, min_200 MHz, plus or minus 0.5 dB. 350 MHz, 3 dB. 20 dB insertion gain. 4.8 dB, 6 dB, noise figure. ZO equals 75.12, ZO equals 50.12. No external components required. Input and output impedances matched to 50,175.12 systems. Surface mount package available. Cascadable. Description: temperature range order code. O2 plus 70 degrees C NE5204N. 8-pin plastic dip. Minus 40 to plus 85 degrees C SA5204N. O2 plus 70 degrees C NE5204D. 8-pin plastic SO package. Minus 40 to plus 85 degrees C SA5204D. November 3, 1987 4-3. Pin configuration. N, D packages. Top view. Applications. Antenna amplifiers. Amplified splitters. Signal generators. Frequency counters. Oscilloscopes. Signal analyzers. Broadband LANs. Networks. Modems. Mobile radio. Security systems. Telecommunications. 853-1191-91260. Synthetix linear products. Wideband high-frequency amplifier. Absolute maximum ratings. Symbol parameter. V supply voltage. VEN AC input voltage. TA operating ambient temperature range. NE grade. SA grade. Max. Maximum power dissipation 2. TA equals 25 C, still air. N package. D package. TJ junction temperature. TSTG storage temperature range. Sold. Lead temperature. Soldering 60s. Notes. 1D rate above 25 degrees Celsius, at the following rates. N package at 9.3 MWRC. D package at 6.2 MWRC. 2C power dissipation considerations section. Equivalent schematic. November 3, 1987. R. Q. Rating unit. 9V. 5VP underscore P. O2 plus 70C. Minus 40 to plus 85C. 1160 MW, 780 MW, 150 C, minus 55 to plus 150 C, 300 C, V, row, R, dash dash M of hour, 4 to 4. Product specification. NEJSA 5204. Synutix Linear Products Product Specification. Wideband High Frequency Amplifier NEJSA 5204. DC Electrical Characteristics at V equals 6V, ZS equals ZL equals ZO equals 50Q and TA equals 25C, in all packages, unless otherwise specified. Symbol parameter. V operating supply voltage range. Li supply current. S21 insertion gain. S11 input return loss. S22 output return loss. S12 isolation. BW bandwidth. BW bandwidth. Noise figure, 75Q. Noise figure, 50Q. Saturated output power. 1 dB gain compression. Third order intermodulation. Intercept, output. Second order intermodulatlon. Intercept, output. TR rise time. Propagation delay. 34. 32. T30 underscore Ta equals 25C. FFI 28. F26. G24. 22. Q. 20. 18. 16. 55.56.5. Supply voltage V. 7.5. Figure 1. Supply current vs supply voltage. November 3, 1987. Test conditions. Overtemperature. Overtemperature. F equals 100 MHz, overtemperature. F equals 100 MHz. DC-550 MHz. F equals 100 MHz. DC-550 MHz. F equals 100 MHz. DC-550 MHz. Plus or minus 0.5 dB. Dash 3 dB. F equals 100 MHz. 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 L. W. A. Shocked. 7U. 3. 5. Z6. 5. 10. Limits. Min tip max. 5-8. 19-24-31. 16-19-22. 25. 12. 27. 12. Minus 25. Minus 18. 200 350. 350 550. 4.8. 6.0. Plus 7.0. Plus 4.0. Plus 17. Plus 24. 5. 5. 20 equals 500. Ta equals 25 degree CAF. VCC equals 8V. A. VCC equals 7V. VCC equals 6V. VCC equals 5V. 68102. Frequency megahertz. Figure 2. Noise figure vs frequency. 4 to 5. Unit. V. Ma. dB. 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 Megahertz. megahertz, dB, dB, dBm, 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 PS, PS. Synthetix linear products. Wideband high frequency amplifier. E. At. I. W. Li. W. E. 2. W. 0. 2. 0. I 0. Z. 0. JW. N. 25. RZO equals 500. RTA equals 25 degrees C. 10. 10. I. VCCFV / VCC equals 6V. VCC equals 5V. 6102. Frequency megahertz. 6103. Figure 3. Insertion gain vs frequency, S21. 11. 10. 9. 8. I5. IIL4. OJ-2. -3. -4. -5. -8. RZO equals 500. RT, equals 25 degrees C. 10. VCC equals 7V. VCC equals 6V. VCC equals 5V. 8102. Frequency megahertz. VCC equals 8V. L. Figure 5. Saturated output power vs frequency. 40. 35. 30. 25/20. /Ta equals 25 degrees C. ZO equals 500. 15. I. 10. 47810. Power supply voltage V. 25. VCC equals 8V. ZO equals 500. 10. 10. Product specification. NE/SA5204. T equals -40J1. Ta equals 25C17. Ta equals 85.C. 681, 2. Frequency megahertz. 68103. Figure 4. Insertion gain vs frequency, S211. 10. 9. 8.6. J. 3. 2. 1. 0. -1. 0 to 2. -3. -4. -5. -8. VCC equals 8V. TVCC equals 7V. RVCC equals 6V. T-VCC equals 5V. FZO equals 500. RTA equals 25C. 10. 68102. Frequency megahertz. Figure 6. LDB gain compression vs frequency. 30. E. 3. I25. W. J. 2, 20. E. I, dash. 2. W15. 0. 2. Ta equals 25C. VZO equals 500. C. 010. 9. Z. / 5. 410. Power supply voltage V. Figure 7. Second order output intercept vs supply voltage. Figure 8. Third order intercept vs supply voltage. November 3, 19B 7426. Synthetix linear products. Wideband high-frequency amplifier. 2.0, 1.9, 1.8, 1.7, 1.6, 1.5, 5, A 1.4, 1.2, 1.1, ZO equals 500, 1.0, 10 feet 6 inches 8102. Frequency megahertz. Figure 9. Input VSWR-VB frequency. 40. IL 35. II. 3000 dash. Dash Z. ZA. 25A. W. WA. A. 20. G15. 10. 10. Frequency megahertz. Figure 11. Input, 511, and output, 522, return loss Vs. Frequency. I. Z. C. Z. W. 3. 25. 20. 5. R. I. 0. 0. VCC equals V. VCC equals 7V backslash dot backslash. I backslash. VCC equals VJ. VCC equals 5V. ZO equals 7S0. T equals 25 degrees C. 68102. Frequency megahertz. T backslash. Figure 13. Insertion gain Vs frequency, 52. November 3, 1987 427. Product specification. NEJSA 5204. 2.0. 1.9. 1.8. A. 1.7 Ta equals 25 degrees C. IL. 1.6. VCC equals 6V. 1.5. 1. 0 1.3. ZO equals 750. 1.2. 1.1 ZO equals 500. 1.0. 08102 8103. Frequency megahertz. Figure 10. Output VSWR Vs frequency. Minus 10. Minus 15. 3. I. Z. 2 to 20. Minus 25. Minus 30. 10. ZO equals 500. Ta equals 25 degrees C. VCC equals 6V. 68102. Frequency megahertz. V. 68,03. Figure 12. Isolation Vs frequency, 5,2. I. Z. 0. Phi W. 25. 20. 15 ZO equals 7S0. VCC equals 6V. 10. 10. Ta equals, 40 dash colon. T equals 25 degrees Celsius. Ta equals 8 SC. 68102. Frequency megahertz. Slash. I. 68103. Figure 14. Insertion gain Vs frequency, 52. I. Signalx linear products. Wideband high-frequency amplifier. Theory of operation. The design is based on the use of multiple feedback loops to provide wideband gain, together with good noise figure and terminal impedance matches. Referring to the circuit schematic in figure 1s, the gain is set primarily by the equation 1. which is series shunt feedback. There is also shunt series feedback due to RF2 and RE2, which aids in producing wideband terminal impedances without the need for low value input shunting resistors that would degrade the noise figure. For optimum noise performance, 1 rupee and the base resistance of 0 are kept as low as possible, while RF2 is maximized. The noise figure is given by the following equation. RB plus RE1 plus JNF equals 10 log 1 plus underscore 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 dot colon 2 QLC1 dB. Rho 2. Where IC equals S dot SMA, 1 rupee equals 12 N, RB equals 130 N. KT slash Q equals 26 MV at 2 SOC and rho equals so for a Sun system and 7s for a 7SN system. VN 3NH. November 3, 1987. The DC input voltage level VN can be determined by the equation 3.